started differential equations, and yesterday we studied what? We introduced what actually differential equation is, and understanding what is the requirement of differential equation, why do we study differential equation. After that, we went to understand what does it mean to say order of a differential equation, and then the degree. The order of a differential equation was nothing but the highest order derivative present in the equation, right? And the degree was if we are able to separate all my derivatives free from if it is free from all the functions, it can be written as a polynomial form, then the power of the highest derivative becomes the degree. And we also understood that the solution of differential equation was nothing but a function. So we are trying to find an unknown function by removing the arbitrary constant. So we also learned how to create differential equations from a family of curves. The only concept was that if there is any parameters, if there are two parameters, differentiate it twice and then use those two equations to get rid of those parameters, and then you're right. So the whole idea is that your differential equation shouldn't have any parameter, right? After that, we started solving some of the differential equations. So the good news was that we have only order 1 and degree 1 in our course. So first we were doing the variable separable form, in which I was separating my y, I was separating my x, and I was taking my separated y's to dy, and I was taking my separated x to dx, and I was integrating it, and then I was finding a general solution in which I was putting c as a constant because that was a general solution. And whenever the points were given, we were able to find the particular solution, right? That was the story. After variable separable form, we found something like what if it is not, if this was the form ax plus by, we were able to substitute it by taking ax plus by as t, and then getting a plus b dy by dx as dt by dx. That was the idea, and then we were able to handle that thing that was easily reduced to variable separable form, and then after then getting back to again resubstitution, right? After that, we understood what is homogeneous function, right? After understanding homogeneous function, we were trying to do the substitution, like if we are able to write my function in the form of y by x or x by y, we were just substituting that by t, and then we were seeing that things are getting easily separated, right? If we have two lines, line 1 upon line 2, and if those two lines are passing through origin, means point of intersections are origin, it means we can easily get homogeneous out of it, and then we can find our solution, right? When we got something like linear upon linear, means two lines, but they are not intersecting at origin, then what we were doing, we were just shifting the origin. We were just shifting the origin to the point of intersection, and then we were able to solve our differential equation, right? After that, what we discussed was, till here we were parallel lines, that can be handled in this way only. We only saw that's why it, right? So now today we'll go further. We'll see what does it mean when I say linear differential equation. When I see something of this sort, we call these type of, where P and Q are constants or function of x. Okay, this is called linear differential equation, right? Now, the idea is whenever we are going to observe this type of differential equation, how we are going to solve it. Okay, we are not going to say right now that if you see that this y and I see dy by dx, right? And I see p here. Somewhere I'm thinking of a product rule. What I'm thinking of? Thinking of a product rule. I'm thinking of function if I differentiate that product, I get one times I get the differentiation of this, and the other side this. So I'm thinking of a function which can give me this and the missing part, means the original function. So exponential function, when we were studying exponential function, we actually thought, we saw that it is quite easy. See, let's say if I get something like dy by dx plus y is equal to 0, right? What are you thinking? That dy by dx is nothing but minus y. So I can say dy by y is equal to minus dx. I can integrate it. I can integrate it. So I'm going to say log y is equal to minus x plus c, which I can see y is equal to c. So I'm getting something like a into e to the power minus x, like exponential function. So somewhere we are understanding that exponential function is something which can help me out for finding a function whose derivative will give me p and it will remain same, right? So what I'm thinking of a function like, what is the derivative of this upper thing, power p? If I multiply everything, I'll get something like the derivative on the left hand side of the product, and right hand side I get q into this. There's nothing but function of x, again function of x. So it's just a product here, right hand side. On the left hand side, we have already got the d part of the function. So now we can easily integrate it. Now this thing is called integrated factor. So you understand why we are using it as an integrating factor, because we observed that I have this linear differential equation and I see p here. I'm thinking of a function as a product rule whose derivative will be p, and that function also has to come because I'm going to multiply somewhere here also. Let's say the function is x, then x needs to be here as well, right? And x and p is nothing but xp is nothing but derivative of x, right? This is the idea, na? So, and then we observe that dy by dx is giving me exponential function, and then we also had a very good exposure to exponential function. We have done a hell lot of differentiation with this, and then we see that okay, exponential is the one which is going to produce, even if it's get, what is the differentiation of e to the power x? We understood that it's nothing but e to the power x, right? That is the idea. Okay, and from the integral calculus class, we understand the integration of p dx is a differentiation of this integration is nothing but p, right? Any problem in this? Okay, so we are going to see whenever we have dy by dx plus py, we are going to think this way. Okay, when we get something like so you understand whenever you are going to see, you are able to recognize it, right? P and Q should be constant, or P and Q should be function of x, and the linear differential equation would be nothing but dy by dx plus py is equal to q. The story can be reverse also. It can be like this: dx by dy plus px is equal to q. Okay, this is also the same story, only y has been replaced by x and x has been replaced by y, right? So you see what the integrated factor is going to be, e to the power, यहाँ पे p and q क्या है, constants or function of y. Getting the idea? No issue with this. So these are the two things which you are going to observe, and you are going to, if you are not able to get dy by dx plus py is equal to q, think of dx by dy plus px is equal to q, right? These are the two. Now the third is called the Bernoulli's differential equation, which you are going to see the third type. See, you can also be exposed to something like dy by dx plus py into q y to the power n. Okay. So it's p and q are the same story. That's a function. It's a constant or a function of x. Now, but here q has also got a company of y. So we must get rid of this, right? So what we are going to do, we are going to divide everything by y to the power n. So you'll get something like, right? Right? Is equal to q. This is the story. Right, from here we came to this. Now, I see y to the power 1 minus n. If I differentiate this, what I'll get? I'll get this. So I can say y to the power 1 minus n as t. So I can say this will be nothing but minus n dy by dx is equal to, can I say this? Of course, this will come. And it's nothing but constant. 1 upon constant. So I can say 1 upon 1 minus n dt by dx is equal to pt is equal to q. I can get 1 minus n on the all sides. So I can say p into 1 minus n, q into 1 minus n. Right? Now again, I got a first order linear differential equation, right? So what the 1 minus n is nothing but constant. So what is going to be my integrating factor? This is going to be my integrating factor, right? So you see all the three types, the linear differential and then the Bernoulli and how to handle them, right? Okay, now we'll try to solve the questions. So you understand how this e to the power p dx is coming, how we are going to think, right? Now the first question in sixth part A, I see sixth A, I see x square dy by dx plus y is equal to 1. Is it my linear differential equation, first order? So I can say dy by dx plus 1 by x square is equal to 1 by x square, right? So my integrand factor is going to be right? This is going to be my integrand factor, which is nothing but x to the power minus 2 dx is x to the power minus 1 by minus 1. So I can say it is nothing but e to the power minus 1 by x, right? E to the power minus 1 by x. So I am going to say e to the power minus 1 by x dy by dx plus e to the power minus 1 by x 1 by x square y is equal to e to the power minus 1 by x 1 by x square. Any issue here? No? What is it? D of, first I'll going to say this. Right? Okay. I can integrate both sides because I can easily integrate this. Is it, you can understand that we can easily integrate this. It's nothing but a product rule of y and e to the power minus 1 by x. Okay. So I can say on the left hand side, it is d to the power d of e to the power minus 1 by x y is equal to, I'm going to substitute this as e to the power t, and then this will be 1 upon et. So e to the power t left hand side में क्या आ जाएगा? E to the power, right? So answer is going to be clear. So this is how you are going to solve your question, right? Now see the second question. Understood? Any problem in this? No? Now you see the second part, it talks about x plus 2y square dy by dx is equal to y. Now here is something like I have got dy by dx with two terms, right? But in linear differential equations, I get only dy by dx or dx by dy with only one term. So I can put my dx there. So I can say y into dx by dy, right, is equal to x plus 2y square. So now, which one should I take on the left side, x or y? X, because I am getting dx by dy. So I should get x there, right? So I can say y dx by dy minus x is equal to 2y square. I can also divide by y. So I can say dx by dy minus 1 by y into x plus 2y. What is going to be my integrand factor? E to the power minus 1 by y dy. Okay, which means e to the power minus log y. Log will cancel, it will turn out to be 1 by y. Right? So my integrand factor is 1 by y. So I need to multiply 1 by y everywhere. So it will be something like 1 by y dx by dy minus 1 by y square x is equal to 2. Right? Now I can say minus 1 by y dx minus 1 by y square x dy is equal to 2. Now I can integrate. There is nothing but x into minus 1 by y is equal to 2y plus c. Clear? No problem? Okay. Now you see the third part. You see third, it's cos y dy by dx plus sin y is equal to x. Now here is the problem. What's the problem? I'm not getting that same form. So with little substitution, can I get it? What should be my substitution? Sin y should be equal to t. So if I say sin y is t, I can write whole expression as dt by dx plus t is equal to x. Now it's simple. You can easily, the integrand factor turns out to be e to the power x. Right? Because here I can see p as 1. 1 into dx is nothing but. Okay? Any problem? No? This was c. Now see the d part. X dy same. You just get, it's a very simple form. So it will be e to the power dx by x. That is e to the power ln x. That is x. So x is going to be my integrand factor. So x square plus xy plus x to the power 4. Clear? So I can get easily that will be nothing but yx square is equal to x to the power 5 by 5 plus c. Right? Okay? D is done. E. Again, the same manipulation. Okay, wait. I have, no, it's fine. I can say dy by dx plus y cot x is equal to 2 sine square x, 2 sine x cos x. So I got the function p and q as function of x, and p is nothing but cot x. So e to the power cot x dx is nothing but e to the power ln sin x, which is nothing but sin x, right? ये होगा ना, cos x upon sin x, so it will be e to the power ln sin x sin x. So integrand factor is going to be sin x. So the question answer is going to be y sin square x is equal to integration of sin 2x dx. Sorry, we are going to multiply with, so sin square x into 2, मतलब कर लेना sin cube x cos x कर लेना, है ना? Clear? Any issue? No. Clear? Now see the f part. How to solve E? F. We have d of xy. D by dx of xy. And there I got x sin x plus log x. And then y. How to go for it? I can differentiate xy. So I can write it in a simpler way that y is equal to x dy by dx plus y is equal to x sin x plus x log x. Easy question. I see dy by dx plus 1 by x 2y is equal to sin x plus log x, and the integrand factor is nothing but x. Integrand factor is going to be nothing but x, because e to the power 1 by x dx is ln x, e to the power ln x is x. Okay, so g dy by dx plus by is equal to e to the power nx. So b is nothing but a constant. So I can say e to the power bx is going to be my integrand factor. So I can easily handle that. H part, dy by dx is equal to y tan x. I am just going to simply put my y minus y tan x on the left side, and then I'm going to say minus tan x as p. So integrand factor is that e to the power minus tan x dx. That is nothing but e to the power ln cos x. Ln cos x is nothing but cos x. So integrand factor is going to be cos x. Okay. So any issue? It's a very easy thing. The only challenging part is to recognize it, right? Can we go to the second page? Next page. Now here we got Bernoulli's, right? See the Bernoulli's. I got dy by dx plus y is equal to 4x. I see y cube there. So I'm going to say y to the power minus 3 dy by dx is equal to y to the power minus 2 is equal to 4x. Right? So y to the power minus 2 is going to be my t. So minus 2 y to the power minus 3 dy by dx is going to be my dt by dx. So y to the power minus is nothing but minus half dt by dx plus t is equal to 4x, right? So it is going to be nothing but dt by dx minus 2t is equal to minus 8x, right? I just multiplied everything by minus 2. So it turned out to be dt by dx, this turned out to be minus 2t, and this turned out to be minus 8x, right? Now what is going to be my p? Right, this nothing but, So this is my integrand factor. I can easily handle it, right? So my answer will come in t and x, and then I'll replace t by y to the power minus 2, right? See the second question, x squared dy dx plus xy. So I'm just first going to divide everything by x square. So it will be 1 by x on the second term, and on the right hand side, I'll get again 1 by x square, right? And then I'm going to divide everything by y square. It will turn out to be y minus 2 and then y minus 1. So I'm going to substitute y minus 1 as t, and then I'm going to handle. Okay? No problem here? Okay. Third part is also very easy. Y square minus y cube. So I'm going to take minus y cube as my t, and then I can replace y square dy by dx accordingly, right? Then y log x minus 1 y dx. अच्छा ये बताओ इसमें क्या करें? First I'll take dy by dx on the right side. Okay. Then I'll say just let's simplify this expression. Y squared log x minus y is equal to x dy by dx, right? So it is nothing but x dy by dx plus y is equal to y square log x, right? What I'm going to do, divide everything by y square and everything by x. So it will be y to the power minus 2 dy by dx plus y to the power minus 1 into x to the power minus 1 is equal to log x by x. I'm going to take this as t. Accordingly, this is going to be removed, and then my answer is going to be very easy. Easy to integrate log x by x, right? Log x in square by 2. Clear? See the e part. Sin y dy by dx is equal to cos y into 1 minus x cos y. So what's the idea here? What the substitution should be? Cos y should be t, and then everything will be fine, right? And then you will get everything in the form of, okay. Till here, no issue. We have seen almost all the types. We are just going to see some exact types. Like it's very important, and it turned out to be one of the difficult part of the differential equation, because you are exposed to this, but you are not exposed. You have to keep in mind everything, right? Like let's say I will see what I'm talking about. See, let's say my first question is x dy minus y dx upon x square is equal to x by y dx, right? I see sometimes I get a little confused. I'm not able to separate my x by y. I'm not even able to write in a homogeneous form, right? But I see this expression, and I have seen hell number of times I have seen this expression. What is this? It's a quotient rule. So I can say it is nothing but d of, and here I saw. So I can shift this to that. So I can say y by x into d of y by x is equal to dx. Right? Now I can easily handle it. I'm going to replace y by x by t. So this will be t dt. T dt is nothing but t square by 2. And here it will be x. So I can say y square by 2x square is equal to x plus c. Getting the idea? These are the exact things. We'll try to remember, we'll keep in mind also whenever we are going to see these type of expressions, we are going to keep in mind. Okay. Now see second part, B part. The B part talks about x dy plus y dx is equal to dx upon x dy plus y dx is equal to dx by xy. Now again, it's difficult until unless we are going to think of product rule. There's nothing but d of, and I'm going to take xy here, and then dx. Easily separated, right? I can easily integrate it. So it will turn out to be x square y square by 2 is equal to x plus c. Clear? These type of expression you should keep in mind. चलो क्वेश्चन टूल आसान था दिमाग में रखना और प्रोडक्ट रूल भी आसान है. अब देखो आगे देखो क्या क्या हो रहा है. देखो ये है मान लो x dy plus y dx अपॉन xy is equal to dx. ये आ गया. ठीक है. अब देखो मैं क्वेश्चन रूल भी नहीं देख पा रहा हूँ, है ना. मैं क्वेश्चन रूल भी नहीं समझ पा रहा हूँ. फिर लेकिन मुझे ये दिख रहा है कि ओके इसका प्रोडक्ट यहाँ पे आ रहा है. तो 1 by t dt, हाँ वो फॉर्म से तुम देख सकते हो, है ना. या यहाँ पे तुम्हारा ये दे रखा है log xy, इस पूरे को t, क्योंकि इसका ये है. तो यू शुड रिमेंबर d ऑफ ln xy is xy x dy plus y dx. So it will turn out to be t square by 2 is equal to x. Right? Getting the idea? How things get complicated. Even if every time you are not going to make this as a product rule. Right? See, the things are going to be very messy. Even if you see that it will turn out to be, final answer would turn out to be ln xy. So you could have thought that it's nothing but d of ln xy. Clear? Now similarly, here it was plus x dy plus y dx upon xy, right? Now in next question it turns out to be in a negative way, that x dy minus y dx upon xy. When I see the numerator, I am thinking of quotient rule, but the denominator I don't see quotient rule here. Right? So first, even I can think this way also, that okay, let this be x square, then I can say x by y. Right? And this is nothing but d of y by x. So actually what I am to think, log of, it's nothing but d of log 1. Getting the idea? Clear? You should able to recognize these things, right? So I can say, so I can handle d part also. Log of y by x will go and turn out to be t dt. That will turn out to be log y by x square by 2 is equal to x plus c. Clear? Now see this e part. It's like x dy minus y dx upon x square plus y square. Okay. Now this has turned out to be d of tan inverse y by x. How? See, I know if I differentiate, see, ये तो मुझे क्वेश्चन रूल का याद दिला ही रहा है ना. तो मैं कम से कम एटलीस्ट ये तो कर ही सकता हूँ इसको एक्स स्क्वायर बाई एक्स स्क्वायर, और ये मुझे याद दिला रहा है 1 प्लस वाई स्क्वायर बाई, तो बेसिकली ये मुझे याद दिला रहा है इसका d of tan inverse. So you should also remember कि d of tan inverse y by x is x dy minus y dx upon x square plus y square. See, these are not very difficult to keep in mind, not even difficult to derive, because you have been exposed to differential calculus, you have been exposed to integral calculus so much that it's fine now. Right? It has become natural now. Clear? Any issue here? No? Now when you see something like x dx and y dy, x dx, it's very easy to guess. You're thinking of x square plus y square, right? So you can handle that also. See, the question is x dx plus y dy upon x square plus y square is equal to dx, right? So I'm going to make this as t, and this turns out to be half dt. So I'll take care of half as well. So half dt upon t, that is log t finally. Okay. Now see the g part. Let's solve g part now. I see y dx minus x dy, y dx minus x dy plus y square cos x dx. Solve it. Divide by y. You want to make it this thing or what? Differential, linear differential equation you are trying to make it. Huh? Quotient rule लगा रहे हो. Okay, very good. फिर so you are going to say that y dx minus x dy upon y square is equal to minus cos x dx. So it is nothing but d of x by y. So this left hand side turns out to be x by y and right hand side turns out to be sin x plus c. Clear? Okay. तुम कहीं वो उसके लिए टेम्प्ट तो नहीं हुए थे लीनियर डिफरेंशियल के लिए? गुड. अगर उसके लिए भी टेम्प्ट होते तो हो जाता, कोई प्रॉब्लम नहीं था. Because it is actually breaking into the linear part. Bernoulli basically, है ना? Now see h part, x plus ln y dy plus y dx is equal to 0. Should I rearrange it? X dy plus y dx is equal to minus ln y dy. I can handle this. I can handle this. This is nothing but xy. Clear? Any issue? These are very easy chapter. Do the I part. I'm giving you 2 minutes. So what are you thinking? Is it a perfect square? Think of that. Perfect square. Think of that. Perfect square. That's a perfect square. That's a perfect square. Now, how to go beyond? कैसे? ये तो हो गया. X square plus y square is t. Then things is solved, right? इसमें क्या करें? ये मुझे कुछ करने को बोल रहा है. Y dx minus x dy is tempting me to do something. Is asking me to do something. ये किसके ऊपर आता है? Quotient rule में आता है. But what is missing? Y square is missing. So I'm just right. Right? So I can handle this. How I can handle this? This will be 2x, 2y, half. So it's nothing but d of the upper part. Right? So t to the power minus 2 dt is nothing but t to the power minus 1 upon minus 1. Right? And what is t? X square plus y square. So x square plus y square का minus 1 नीचे आ जाएगा. This is nothing but d of y by x. And it is nothing but t square. So t square dt is t cube by 3. Clear? You have to do little manipulation, little cooking up, okay, how things are, we are arriving, right? So this was basically your exact differential equation. Next page. You understood? Any issue here? No? So we have almost seen all the types we have. It's there in the syllabus. We'll also try to see some of the differential equation of first order but little higher degree, but it can easily be solvable for p, it can easily be solvable for x and y. We'll see that also, but right now we are going to see something else. Let's say this is my curve, and let's say p is any arbitrary point. Okay, p is any arbitrary point whose coordinate is, let's say, x comma y. Okay, I'm going to say this is my capital X axis and this is going to be my capital Y axis. Okay, P is any arbitrary point on the curve x comma y. I'm going to draw a tangent on P at P. Okay, tangent at P. This is going to be my tangent at P, right? I'm going to call this as PT, right? And I'm going to this 90 degree here passing through P. What that line is called when that line is perpendicular to tangent and passing through the point of contact, the tangency, that's called normal. So this line is called normal. So I'm going to call this as PN. Any issue here? No. This is my tangent and this is my normal. Now this is tangent, so I know it is making angle theta. So tan theta is nothing but dy at P. Clear? Now this point, I'm dropping a perpendicular here, right? What is the length of this line? Y. I'm going to call this point as M. Okay. Now I can understand what is my tangent. I can understand what is my normal. This PN length, I'm going to call length of normal PN. Right? Length of normal is my PN, and length of tangent, this PT line, is my length of tangent. Right? This length is nothing but the ordinate of P, and this length TM is called subtangent, and this length MN is called subnormal. Right? You understand this in issue here? Now, what is the equation of PT? Equation of tangent is going to be capital Y minus Y, capital X minus X is equal to at x comma y, smallest xy. Okay? So this is going to be my equation of tangent. And what is the equation of normal? I know it is nothing but the same line perpendicular to tangent and passing through the point of tangency, right? So what is the equation of normal? Y minus y, x minus x is equal to minus 1 by dy by dx at x comma y. Clear? So you understand what is the equation of tangent, you understand what is the equation of normal, right? Now, you understand OP? What is OP? It's just a distance of P from origin, and you can say this is nothing but under root x square plus y square, right? Now tell me, what is the length of PT going to be? If you see, observe this right triangle. I know this is y, this is known, and dy by dx is known. So what is going to be my tan theta? What is going to be my PT? I know y by PT is nothing but sine theta, right? Y by PT is nothing but sine theta. So I want to find PT is equal to y cosec theta. Okay, what is cosec theta? Cot square theta plus 1 is cosec square theta. So I can say y is equal to under root 1 plus cot square theta, right? And I can write cot square theta is nothing but dy by dx by dy, or 1 upon dy by dx square. So I can say the length of tangent PT is going to be y into under root 1 plus 1 by dy by dx square, which is nothing but y into 1 plus dy by dx square upon dy by dx, right? This is going to be my length of tangent, this PT, length of tangent. So you understand what is how to find the length of tangent? Nothing, a simple geometry. It was nothing but y by PT is nothing but sine theta. So of course PT turns out to be y cosec theta, and I know cosec square theta is 1 plus cot square theta. So I say y into 1 plus cot square theta, and I know cot square theta is nothing but 1 upon tan square theta. So I'm going to write y into 1 plus dy by dx square upon dy by dx, right? So this is how we are going to find the length of tangent. Now similarly, observe this length Pn. It's nothing but length of normal. If this is theta, this turns out to be 90 minus theta. So this turns out to be theta, right? Now I know this is y. I see this triangle. So I know y by Pn is cos theta. So Pn is nothing but y. And what is sec theta? Clear? Any issue? No. So we have already found length of tangent. We have already found length of normal. Now observe here. Tm. Tm is nothing but length subtangent. So subtangent is going to be y by Tn is equal to dy by dx. So Tn is nothing but y by, clear? And what about Mn? Mn is nothing but subnormal. I know y by Mn Mn by y is equal to, so Mn is so this is the story. You understand what do you mean by subtangent, you understand what do you mean by subnormal, you understand what is length of tangent, what is the length of normal, you understand what is this line dropped perpendicular on x-axis, okay, and what is this length going to be, you understand xy is just any arbitrary point, okay. Equation, you know how to write equation, you know how to write equation of normal. So any problem here? No? Okay. So now we will try to see the questions and we'll try to solve the questions, right? Shut it a bit. So basically everything, what we understood out of it, we were actually, there was an unknown function and whose derivative is given and there's some certain information has been given. So we are able to connect that derivative with the prescribed information, and then it would be very easy for us to find the general function as well as if there is information going about the particular ones, we can easily find particular equation, right? Understood what was the idea? The only thing which you were like must not be aware of, that was subtangent and subnormal. Otherwise, rest of the thing you have been already dealt in class 11th, right? So you understand what is subtangent, what is subnormal? Subtangent is nothing but जो आप tangent draw करो and normal draw करो and then drop the ordinate foot of perpendicular from the point. So your x-axis is divided into two parts. One part is called subtangent, other length segment is called subnormal, right? Okay, see question number 9. The slope of curve passing through 4, 3. So I know this curve is passing through 4, 3. Okay, so I'm going to find a particular solution now. At any point is the reciprocal of twice the ordinate at that point. What is ordinate? Y. Show that the curve is parabola. So the only idea I can see that dy by dx is equal to the slope of curve passing through is reciprocal of okay, this is the idea. So I know how to solve this equation. So I'm going to say 2y dy. I told you know why this differential equation was used. It was used just to find the unknown function. It was so it was nothing but y square x plus c. It is my general family of curve and it's a parabola. And what is the equation of this curve going to be? 9 is equal to 16 plus c. Sorry, 4 plus, so c is going to be 5. So my equation is going to be y square is equal to x plus 5. It is a parabola. What is going to be the graph? x plus 5 है ना, तो vertex क्या होगा? -5, 0. This is going to be my parabola, right? Clear? आप लोग, are you guys revising class 11? Because after January you won't have any time, because February and March will go poop because of the boards and all. पता भी नहीं चलेगा. And till now you should create a flashcards. You understand what is flashcards? You should have a flashcards in which you are writing all the results. Paste all the results of coordinate geometry and all the important trigonometry complex numbers on your study table, so that you are actually, when you are not even studying, you are being exposed to everything. Try to create a map of every chapter, like all chapter can be summarized in one board, right? So try to make it, right? And then whenever you are traveling, use flashcards to see, right? Because you don't have much time now. Because after boards you won't have any time for mains, and mains में आपको class 11 का knowledge जरूरी है. You should score good marks in mains. Otherwise, let's say if you are not able to perform good in advance, the score of mains will matter to get you in other NITs and all. So mains, you cannot ignore mains like it's just a qualifier. If you are very sure that you are going to score very good in advance, then you can treat it as a qualifier. Okay. Do question number 10. The question is, find the equation of the curve passing through 2, 1, which has constant subtangent. What is subtangent? That length, you know. You know the relation? Just tell me, what is the quadratic equation? What is the differential equation you have formed? What was subtangent? It was subtangent, right? Theta, y. This part was subtangent, है ना? It is nothing but y by subtangent is equal to dy by dx. So subtangent is nothing but y by dy by dx. यही था ना? And what is subtangent? Is it constant? So I can say subtangent is nothing but k. So I can say k dx, sorry, k dy is equal to y dx. I can say this. कह सकते हैं ये? So I can say k dy by y is equal to dx. So what is dy by y? K ln y is equal to x plus c. From where it is passing? 2, 1. So I'm going to put x as 2 and y as 1. So this will go off. This will be 2 plus c. So c is going to be, so what is the equation? K log y minus, sorry, x minus 2. Right? And how to write in exponential form? Y is equal to e to the power x minus 2 by k. Or you can also say e to the power minus 2 by k into e to the power x by k, which is nothing but a into e to the power. So it's just an exponential function. You can draw the graph as well, right? So understood 10th question? Now see the 11th part. Find the curve through 2 comma 0. Again, we have to find a particular solution so that segment of tangent between point of tangency and y-axis. So you see the segment between point of tangency and y-axis. You understand y-axis? Has a constant length and that is equal to 2. We'll just draw a rough diagram. It's telling something like it's talking about this point, hai na? This length. And he's saying this length is 2. This is x comma y. Okay. Now this is tan theta. So I can develop my equation, and it is the curve is passing through 2 comma 0. Okay, no issue. So this length is 2, है ना? अब हम क्या कहते हैं? What we can create? What is the differential equation we can create? Ma'am? I know this is x. So I can say 2 cos theta is y is equal to? No, y won't be equal to 2 sin theta. Okay, I can say x is equal to 2 cos theta. Okay, now cos theta is nothing but x. Sec theta is equal to 2. And what is sec theta? Is equal to 2. So I can say 2 by x. So I am going to square it up. So 1 plus dy by dx square is equal to 4 by x square. Clear? So dy by dx square is going to be 4 by x square minus 1. So dy by dx turns out to be 2 curves. 2 कर्व आ रहे हैं ना? एक क्या हो गया? 4 minus x square under root upon x और एक upon x, right? I can handle it. How to handle it? I can substitute this. Dx will go to this, and then I'll get one curve out of this. Can I solve this equation? I can solve it. Can I solve this? I can solve this. So you can handle both, and then just put the point 2 comma 1. They should satisfy. Sorry, 2 comma 0, and then you get the C part. Clear? See the 12th question. Find the equation of the curve passing through origin if the midpoint of the segment of normal drawn at any point of curve and the x-axis lies on the parabola 2y square is equal to x. So try this question. Equation of curve is passing through origin, means we have to find again a particular solution. If the midpoint of the segment of the normal drawn at any point of the curve, you know the normal, है ना? So midpoint is talking about the midpoint. So आपको ये पता है point of tangency x, y, आप वो point निकाल सकते हो जहां पे normal जा रहा है. You know equation of normal, so you can find in terms of dy dx. तो उन दोनों के मिड पॉइंट क्या हो जाएगा? 2y स्क्वायर इज इक्वल टू x पे मीट कर रहा है, तो उसको सेटिस्फाई करना चाहिए. लेट्स सी हाउ टू गो फॉर इट. If this is your what is going to be your equation of normal? फॉर अ टाइमिंग अभी हम tan थीटा लिखते हैं, ठीक है, बाद में कर देंगे. So I want my x intercept, so I should put my y0. So x is going to be x plus tan theta, right? So one point is x comma y, another point is x plus tan theta comma 0. So midpoint is going to be x plus half tan theta comma y by 2. Here x plus x become 2x, then divided by 2. That way. Now this point must satisfy 2y square is equal to, so 2 into y square by 4 is equal to x plus half. Clear? Solve it. So how to solve this question? Solved? Not solved. X plus t of tan theta, comma y by 2. अब हो जाएगा. There was this mistake. Tan theta y tan theta. So now the equation is solvable, right? Y tan theta हो गया ना? Clear? Not clear? So you can easily solve it. It becomes a Bernoulli now. Why you were not checking? That you were not able to get the Bernoulli. You must check now. There must be some issues. Okay, now question number 13. Find the equation of curve which intersects the hyperbola xy is equal to 4. Xy is equal to 4 is going to be a hyperbola. You know it? What is that hyperbola is called? Rectangular hyperbola. And now what's the diagram? We have already seen. Right. What is rectangular hyperbola? Definition क्या होता है? You're not revising class 11th. Okay. Find the equation of the curve which intersects the hyperbola xy is equal to 4 at an angle pi by 2. What does it mean? When I say angle between the curves, angle of intersection between two curves, I'm talking about, if I say this circle and this circle, and I want to know the angle of intersection of these two circles, what I actually want to know? Angle between the, right? This is what I want to know. Similarly, I have to find a curve which is with hyperbola, कोई curve है, which is making, tangents are making 90 degree. So dy by dx और उसके dy by dx में फर्क क्या है? Product should be -1. Okay. So I have to find. So what I have to find? I have to find other equation of the curve. So I'm going to call that m1 is equal to dy by dx, right? Or hyperbola ka I'm going to call this as m2. And now I'm going to find m2 for hyperbola. It turns out to be dy by dx plus y. X dy by dx plus y. So I turn out to be, m2 turns out to be minus y by, m2 turns out to be minus y by x, and m1 is nothing but dy by dx. So m1, m2 should be, so I can say minus y by x into dy by dx is equal to -1. So I can say y dy is equal to x dx, right? कह सकते हैं ना? So this turns out to be y square by 2 is equal to plus c. What is it? It's again a hyperbola. Or other way also we could have find another curve as well. Let's see. This m2 is nothing but minus y by x. And what is y? 4 by x. So I can say minus 4 by x square into dy by dx is equal to, so I can say 4 dy is equal to x square dx. So I can say 4y equal to x cube by 3 plus c. ये भी कर होगा. Clear? Find the orthogonal trajectories of the hyperbola xy is equal to c. What is the difference between 13 and 14? What is orthogonality? What is orthogonality? Orthogonality. When two curves intersect at 90 degree. So that is what he's asking, the same question. So it will turn out to be the same question. Right? There is no difference in 13 and 14. Right? Any issue? No? You can handle it? Same. It will turn out to be I am going to call M1 as dy by dx, and the other one is going to be 1 dy by dx is equal to x dy by dx into y is equal to 0. So dy by dx is minus y by x. So I'm going to call dy by dx is equal to into minus y by x is equal to minus 1. Right, same story, x square plus is equal to y square plus c. Okay. Now solve 15th question. 1 plus e to the power x by y dx plus e to the power x by y into 1 minus x by y dy. How to solve this question? x by y को t, उससे क्या होगा? फिर पहले इसको ऐसे लिख दो. है ना? And then I'm going to call x ठीक है. So I'm going to call x is equal to my. है ना? So I'm going to call dx by dy is equal to m plus y dm by dx. So everything turns out to be m plus y dm by dy into 1 plus e to the power m is equal to m minus 1 into e to the power m. ये हो गया? ये हो गया ना? फिर क्या करें? m plus y dm by dy is equal to m minus 1 e to the power m upon e to the power m plus 1, and then minus m. Now it can easily be solved, right? It will be y dm by dy is equal to m e to the power m minus e to the power m minus m e to the power m minus m upon e to the power m plus 1, right? सॉल्व हो जाएगा, आप सॉल्व करो. So it will turn out to be, ये उधर चला जाएगा, e to the power m plus 1 upon e to the power m plus m is equal to minus dy by y, and then we can easily handle it. Clear? And then substitute back m as x by y. Clear? So 15, no issue. What about 16? Solve 16. Solve 16. 1 plus x and then minus, how to go for it? क्या करें? Right? This can be easily integrated. This can be easily integrated, and integration of a sum and sum of integration are equal, right? And this is nothing but 2 डालो, half करो. This becomes under root t, and this is dt. Solve. Clear? 17, determine the equation of curve passing through the origin in the form y is equal to fx, which satisfy the differential equation dy by dx is equal to sine of 10x plus 6y. Basically, he's asking you to solve this question. Right? And then find the particular solution. How to go for this? Yesterday we did this type. Yeah? 10x plus? Very good. So 10x plus 6y turns out to be t, then 10 plus 6 dy by dx turns out to be dt by dx. So dy by dx turns out to be 1 by 6 dt by dx minus 10. Right? Okay. So I can say 1 by 6 dt by dx minus 10 is equal to sine t. So I can say dt by dx minus 10 is equal to 6 sine t. So I can say dt by dx is equal to 10 plus 6 sine t. So dt by 10 plus 6 sine t is equal to dx. How to solve this? I can write sine t as 2 tan t by 2 upon 1 plus tan square t by 2, and I will substitute tan t by 2 as x or y or anything p, and then I'll get the dp upon quadratic expression. So I can solve this. I can solve this plus c, and then that thing needs to be balanced because it is passing through which point? Origin. So x is equal to 0 and y is equal to 0 must satisfy this. Okay. Next page. So see how to solve this question 18. Try. You've already been exposed to various forms. Then what? Then okay, solve. See, this exact form is how much it is helping, right? है ना? आपको recognize करना आ गया ना exact form? Solve 19. Is it not telecasting? Now see the 19th one, x dx plus y dy. So right hand side everywhere you see x square plus y square, right? It gives you a good hint. But there you see how to go for it. I'm going to say x dx plus y dy into under root x square plus y square. I can handle this is equal to 1 minus x square plus y square into x dy minus y dx. Right? Now what to do? क्या करें? इसको इधर ले जाते हैं. फिर अब क्या करें? हाँ, व्हाट इज मिसिंग हियर? एक्स स्क्वायर। तो क्या करें अब? एक्स स्क्वायर से डिवाइड किया, फिर एक्स स्क्वायर यहाँ लाना होगा, फिर क्या करें? किधर लेंगे एक्स? इस तरफ, यहाँ। उससे क्या होगा? फिर क्या हो जाएगा? हाँ, सोचो सोचो। क्वेश्चन तो यही है। स्प्रिंट नहीं क्वेश्चन है। एक्स डी एक्स प्लस वाई डी वाई। एक और फॉर्म याद करो, एक्स डी वाई माइनस वाई डी एक्स वाला। क्या फॉर्म था? लॉग वाला। उससे कुछ हो रहा है? नहीं हो रहा है? कुछ याद आ रहा है? ये फॉर्म क्या था ये? हो गया है ना? एक्स डी वाई माइनस वाई डी एक्स को एक्स स्क्वायर डालो, वाई स्क्वायर डालो, कोई फायदा नहीं है। बट दिस फॉर्म इज नोन फॉर्म। एक मिनट पीछे पेज पे जाएगा। 6C वी हैव ऑलरेडी सीन दिस। एक और पेज डाउन, सी ई पार्ट है ना? क्या था ये? tan इनवर्स y बाई एक्स। बेसिकली क्या हुआ? वही चीज हो गया, 1/y² बाई एक्स स्क्वायर हैंडल्ड। क्लियर? सो यहाँ पे एक्स स्क्वायर प्लस वाई स्क्वायर मैं इजिली यहाँ पे लाके रख सकता हूँ। फिर ये अंदर आ जाएगा एंड आई नो हाउ टू हैंडल √1 - t/√t। है ना? हमने किया था ये क्वेश्चन, √t × 1 - t। तो अंडर रूट क्वाड्रेटिक फॉर्म आ गया। अंडर रूट क्वाड्रेटिक यू नो हाउ टू हैंडल इट, राइट? इट वाज गुड क्वेश्चन, राइट? जल्दी क्लिक नहीं करेगा, है ना? लेकिन एक तरफ तो एक चीज लेकिन बता रहा है कि क्वेश्चन सॉल्व तो होगा ऐसे ही। वो क्या बता रहा है? ये और ये अकेला बेचारा वहां पे पड़ गया है, तो उसको हैंडल करने के लिए हम हमेशा क्वोशिएंट रूल के बारे में सोच रहे हैं। tan इनवर्स वाला भी बंदा हमें हेल्प करेगा। अगर एक्स वाई नीचे लाना होगा तो फिर कौन मदद करेगा? लॉग वाला बंदा, है ना? ओके, नाउ सॉल्व 20th क्वेश्चन। वाज इट कौन सा फॉर्म है ये? पहले ठीक कर देते थोड़ा इसको। इधर है cos स्क्वायर वाई, तो उधर क्या हो जाएगा? sec स्क्वायर वाई dy बाई dx। plus x into 2 sin y cos y upon cos square y. अब तुम्हें समझ में आ गया होगा क्या करना है. So this is gone tan y बन गया है. तो tan y को क्या मान लो? t. So dt by dx plus 2xt is equal to x cube. What is it? Linear. What is the integrating factor? So multiply all sides by e to the power x square, and then answer would be t into e to the power x square is equal to e to the power x square x cube dx. Handle it by parts and then replace t by tan y. Clear? C20 first. A normal is drawn at a point P, X, Y of a curve. It meets x-axis at Q. Okay. And if PQ is of constant length K. Okay, so PQ is nothing but length of normal. Then show that the differential equation describing such curves is y dy by dx is equal to plus minus under root k square minus y square. Also find equation of curve if it is passes through 0, k point. Very easy question. पहले तो proof कर दो. y by this length क्या दे रखा है? y by k is equal to cos theta. Y by k will be equal to cos theta, na? There's under root 1 plus ये होगा ना? Sorry, cos theta is 1 upon sec theta. ये होगा. So I can say y square into 1 plus dy by dx square is equal to k square. So I can say y square dy by dx square is equal to k square minus y square. So I can say y dy by dx इससे आसान क्या होगा, है ना? अब इसे सॉल्व करना है. दो कर्व निकल के आएंगे, एक बार प्लस के साथ एक बार माइनस के साथ. सॉल्व करो. सी डिफरेंशियल इक्वेशन में कुछ भी नया नहीं है, सिर्फ इंडेफिनिट इंटीग्रेशन के इक्वेशंस हैं. So you can say that y dy upon under root k square minus y square is equal to dx. एक बार प्लस के साथ और एक बार माइनस एक बार प्लस. इसको सब्स्टिट्यूट कर दो -2 हाफ करके, हो जाएगा सब्स्टिट्यूट. फिर से इसे कर दो -2 माइनस हाफ करके, हो जाएगा सब्स्टिट्यूट. एंड देन आई कैन हैंडल इट. राइट? Easy question. Is it passing through any point? Yeah, it is passing through 0, k point. So find the particular solution. Okay. Question number 22. A curve y is equal to fx passes through the point p1, 1. ठीक है? The normal to the curve at p is, देखो equation of normal दे रखा है. If the slope of the tangent at any point on the curve is proportional to the ordinate of that point, मतलब dy by dx is ky, है ना? Determine the equation of curve. Also obtain the area bounded by the y-axis, the curve, and the normal to the curve at p. Okay, it means आपको निकालना ही होगा. क्या होगा बताओ? So I know dy by dx is proportional to, ये एक इंफॉर्मेशन दे रखा है कि हमने अपने से इंट्रोड्यूस किया, सो के को निकालना होगा कहीं, ठीक है. और दूसरी बात क्या है कि जो इक्वेशन ऑफ कर्व है, इट पासेस थ्रू 1 1, सो आई कैन से norm y minus 1 upon x minus 1 is equal to minus 1 by dy by dx. Clear? This equation of normal, which I can say dy by dx into y minus 1 is equal to minus 1 of x minus 1, which I can say dy by into y minus 1 plus x minus 1 is equal to 0. And I also know the equation of curve is a by 1 y minus 1 plus x minus 1. Both are same equation. So I can say dy by dx at 1 comma 1 is equal to a. ये dy by dx किसी भी पॉइंट के लिए, ठीक है. तो a की वैल्यू क्या हो गई? k is equal to, क्लियर? क्योंकि dy by dx ये जनरल कहानी है, तो dy by dx at 1 comma 1 क्या होगा? k. dy by dx at 1 comma 1 क्या है? a. तो k क्या हो गया? a. So dy by dx क्या हो गया? ay. Now we can solve it. क्या होगा? Right? ln y is equal to ax plus c. तो y is equal to k e to the power ax. ये होगा ना? ओके, 1 comma 1 पे सेटिस्फाई करना चाहिए. व्हाट इज k? e to the power, तो बेसिकली क्या हो गया? y is equal to e to the power, this is your curve. अब तुम्हें एरिया क्या निकालना है? Find the area bounded by the y-axis and the curve and the normal to the curve. So let's draw the diagram. So this, you understand the curve is y. You know y is equal to e to the power x. You know how to plot this. x minus a मतलब कहाँ shift होगा? Graph will be shifted horizontally to the right a unit, right? 20 सेकंड में 20 सेकंड 21st इससे पहले वाला जो डिस्कस कर रहे थे। एक मिनट ऊपर कीजिएगा, क्या हो गया इसमें? What's the issue? Tell me. A normal is drawn at a point px 22. हाँ नीचे ही है। क्या हो गया इसमें? It's act if this क्या था? e to the power y क्या आया था? e to the power k e to the power x minus x आया था, ax आया था। Okay, okay, okay. So k turns out to be, है ना, क्योंकि y 1 satisfy कर रहा है ना इक्वेशन को। The curve is passing through here, so the y turns out to be y is equal to a into x minus 1। ये होगा, सॉरी, है ना। तो at x is equal to a क्या हो गया? y is x at x is equal to 1, y turns out to be 1। ठीक है, ये कहानी हो गई, है ना। ये कर्व हो गया, ये पॉइंट क्या हो गया? e to the power minus a, है ना, 0, e to the power minus a। क्लियर? दिस इज योर कर्व। 1, 1 पे ही नॉर्मल बना रहे हैं। दिस इज नॉर्मल, राइट। सो यू हैव टू फाइंड दिस एरिया एंड दिस एरिया। ये तो इंटीग्रेशन से निकल के आ जाएगा। क्या होगा इंटीग्रेशन? 0 से 1 e to the power a x minus 1 dx। ये डालो, हाफ ए करो, सॉल्व करो, ये आ गया। एंड दिस इज 1। दिस पॉइंट क्या है? ये पॉइंट देखो, पुट कर दो y को 0, तो y 0 हो गया, तो x minus 1 is equal to a, so x is equal to a plus 1। तो ये पूरा पॉइंट हो गया a plus 1, तो ऑब्वियसली ये क्या हो गया? a, तो ये हो गया a by 2। इसका एरिया a by 2 हो गया, और इसका एरिया हाफ ये कर दो, तो क्या हो गया? 1 by a, ये हो गया e to the power t dt ना। e to the power t dt is nothing but e to the power a x minus 1, 1 से 0 ले जाओ, तो क्या हो गया? 1 by a 1 माइनस, ये हो गया एरिया, प्लस a by 2। क्लियर? सी द 23rd क्वेश्चन। Find the equation of the curve such that the distance between the origin and the tangent at an arbitrary point is equal to the distance between the origin and the normal at the same point। मतलब you have to find the equation of curve। I don't know about the curve, but I know that distance between the origin and the tangent at an arbitrary point is equal to the distance between the origin and the normal at the same point। मतलब नॉर्मल भी उसी पॉइंट पे ड्रॉ कर रहे हैं, और तो आर्बिट्री पॉइंट मान लो h, k मान लो, या x, y ले लो, जो लेना है लगता है। ठीक है, चलो x, y लेते हैं। और पहले मैं इक्वेशन ऑफ टैंजेंट लिख लेता हूं। ठीक है, ऑब्वियसली t कैपिटल D ठीक है, अंडरस्टूड। और दूसरा इक्वेशन क्या हो जाएगा? y minus y upon x minus x is equal to, क्लियर? ये नॉर्मल है, ये टैंजेंट है, ये नॉर्मल है, और इसका डिस्टेंस फ्रॉम ओरिजिन इज इक्वल टू डिस्टेंस ऑफ दिस फ्रॉम ओरिजिन। तो मुझे डिस्टेंस फॉर्मूला आता है, तो आई कैन से, मैं रीअरेंज कर रहा हूं इस इक्वेशन को, तो आई कैन से y माइनस वाई इज इक्वल टू, मैं डी वाई पे डी को अभी m लिख रहा हूँ, mx minus mx, right? So it turns out to be mx minus y plus y minus mx, right? Is equal to 0. और इसको मैं लिख रहा हूं my minus my is equal to minus x plus x. Clear? So I'm writing it x plus my minus my plus x is equal to 0. ठीक है, इसका डिस्टेंस क्या हो जाएगा, mod of y minus mx upon under root 1 plus m square is equal to mod of my plus x upon, clear? This gone. I can say y minus mx is equal to plus minus my plus x. Clear? अब m को रिप्लेस, दो कर्व आ गए, एक बार प्लस के साथ एक बार माइनस के साथ, put m as dy by dx, solve the differential equation, find the curve. ठीक है, यही बस बताना था. क्लियर? डिफिकल्ट? करो, सॉल्व करो, देखो इसको क्या आ रहा है. You have to wind up at 11:15 now. नहीं, 15 now. So we are having just only 15-20 minutes left. So till today we'll be discussing differential equation till here. After that, in the next class tomorrow, we'll discuss IIT questions and other questions. Okay. Today, in the last 20 minutes, I want to discuss about inverse trigo. We couldn't discuss inverse trigo, right? The graphs of inverse trigo. You guys want to discuss that? Inverse trigo. So we are going to discuss how to plot inverse trigo graph. Okay, finished? Okay. So finally, the next class would be the last class of calculus. Finally, it's coming to an end. So I hope you all enjoyed it, and we'll have. I'll keep. We'll be discussing more difficult questions in the next class, and I'll try to touch even other part of differential and integral calculus as well. And today, last time we couldn't discuss the graph of inverse function. So we'll first discuss the graph of inverse function. First of all, you must be knowing what is inverse function. When we say that a function is invertible, when the function is bijective, what does it mean when I say function is bijective? 1, 1 and on 2. Of course, if the function is many 1, we cannot come back, right? If I'm going from, this is a many 1 function. From left to right, it is a function defined, but from right to left, it is not defined because it becomes a relation. It's not a function because for one input, I cannot get two outputs. That is the definition of function, right? So this is the story. So we must understand that for finding the inverse function, the function must be bijective, that is 1, 1 and on 2. So can we create inverse of any many 1 function? No, we cannot. Then how can we are finding inverse of this? Sin x, it's a many 1 function, right? Sin x is a many 1 function. It repeats after 2 pi, every 2 pi. So how we are finding the inverse part? We are breaking the interval in which we are chopping it. We are chopping it into the branches in which we are only getting my 1, 1 relation, right? So when I see the graph, it turned out to be this one, right? And then I saw minus pi by 2, and then pi by 2 to 3 pi by 2. So I see various branches where we can define it as a 1, 1 story. This branch, minus pi by 2 to pi by 2, is called principal branch for how many functions? Sine inverse x, tan inverse x, and cosec inverse x. इनके लिए क्योंकि sin x का प्रिंसिपल ब्रांच है minus pi by 2 to pi by 2, tan x का प्रिंसिपल ब्रांच है minus pi by 2 to pi by 2, and cosec x का भी प्रिंसिपल ब्रांच क्या है minus pi by 2 to pi by 2, where pi by 0 is not included. ये थी स्टोरी. तो बिल्कुल हम लोग इनवर्स उसी के लिए निकाल रहे हैं. और 0 से पाई किसकी करनी है? cos inverse x एंड ठीक है, यहां तक कोई डाउट नहीं है. अच्छा, आपको ये भी पता है कि इनवर्स फंक्शन क्या होता है? सिमेट्रिकल अबाउट y इक्वल टू x लाइन, अपने ओरिजिनल फंक्शन के उसका मिरर इमेज है. तो as far as the graph of sin inverse x, tan inverse x, cosec inverse x, cos inverse x, cot inverse x, it's not a big deal. You just have to draw cos x, take the mirror image about y is equal to x line, right? And you know the principal branches. So basically, जब y is equal to sin x मैं principal branch के लिए देखूंगा, तो डोमेन क्या हो जाता है? माइनस पाई बाई 2 से पाई बाई 2, है ना? और रेंज क्या, y क्या हो जाता है? -1 से 1. For inverse, this becomes your domain and this becomes your range. Clear? यहाँ तो कोई डाउट नहीं है. When you have to develop the graph of only thing which you have to keep in mind is the domain and range. That's it. I know sine of sine inverse x is nothing but x. But what is x? X should lie from -1 to 1. So it becomes a simple y is equal to x line. From where to where? Is it a line or a line segment? It's a line segment. It's ending here, beginning from here, right? This is your sine of sine inverse x. Your sine inverse is inside, and sine inverse is nothing but it's talking about angle. It's inside and it's outside, right? When I talk about tan of tan inverse x, I say that x can go from minus infinity to infinity. So it's going to become a line. And when I say cosec inverse x, easy? Is it difficult? No? Same story. Cos of cos inverse x. It is also going to be minus 1 to 1. तो सेम स्टोरी है क्या? इसकी ग्राफ सेम होगी, इसकी और cot of cot inverse x की भी ग्राफ सेम होगी. Get the idea? No issue here. तो जब भी बाहर है साइन, अंदर है साइन इनवर्स, it's very easy to draw. Let's say एक फंक्शन है gx जिसका पीरियड है t. ठीक है, तो ये बताओ f of gx का टाइम पीरियड क्या होगा? से मतलब ये पीरियोडिक होगा ना? Of course it is repeating after t, so it will also repeat after t. Clear? No issue here. Let's say you have to create y is equal to sine inverse sine x. Of course, I'm not going to see outside because I don't know whether it is periodic or not, but I know it is periodic and it is repeating after 2 pi. It is repeating after 2 pi, so this function is also going to repeat after 2 pi. Clear? If this is my periodic function, this is also going to be my periodic function. Now, since I know sine inverse की रेंज कहां से कहां तक होती है? माइनस पाई बाई 2 से पाई बाई 2 तक ही रेंज होती है. तो आई कैन से sine inverse sine pi by 2 becomes 1, so sine inverse becomes clear. ये होगी नहीं स्टोरी? यहां तो कोई डाउट है? नहीं डाउट है? तो यू नो till here it is this y is equal to x line. Till here it is y is equal to, फिर उसके बाद क्या होगा? अग्री? यही होता है ना सेकंड क्वाड्रेंट में. He cannot give you obtuse angle. सेकंड क्वाड्रेंट में ये फिर से क्या देगा? Clear? This is pi. This is minus pi by 2. And this is pi by 2. कितना हो गया पीरियड? 2 पाई हो गया. अब क्या होगा कहानी? So this is the story of sine inverse sine x. What is the equation of this graph? Y is equal to x. This graph minus x plus pi. क्यों? और इसका ग्राफ क्या होगा? माइनस एक्स माइनस पाई. क्लियर? और उसके बाद कहानी x प्लस x माइनस 2 पाई. क्लियर? ये 2 पाई है ना? It's easy to write the equations. तो अब तुमको जब भी साइन इनवर्स की कहानी हो, you can actually interpolate things. क्लियर? तो तुम्हें लेफ्ट ब्रेथ अपना पता है, पीरियड पता है साइन व साइन एक्स का. सिमिलरली यू कैन डेवलप फॉर इसका पीरियड क्या है 2 पाई, इसका टाइम पीरियड 2 पाई है तो इसका भी टाइम पीरियड 2 पाई होगा. लेकिन ये ग्राफ कहां से कहां, ये ऊपर उठ जाएगा, 0 to पाई की कहानी रहेगी, क्योंकि इसका जो इनिशियल डोमेन और रेंज था उसके हिसाब से ही काम करेगा. तो इसका प्रिंसिपल रेंज क्या था 0 to पाई, साइन इनवर्स का था -π/2 π/2, इसका था 0 to पाई. इट विल अगेन बी अ सॉरी cos इनवर्स cos 0 is 1, cos 0 तो फिर से यही हो जाएगा है ना, cos 0 is 1, so cos inverse 1 is 0, so it will be y is equal to x line and this will be, ये देखो यहाँ पे टच करेगा, ऐसे करेगा, तो ये पॉइंट क्या होगा, ऑब्वियसली ये -x तो डाल ही दो क्योंकि स्लोप नेगेटिव है, और दिस पॉइंट इज 0, दिस इज पाई प्लस पाई, क्योंकि इट इज राइट साइड में है ना. ओके, गेट द आइडिया. सो यू कैन राइट cos इनवर्स cos x as well, sin इनवर्स sin x as well. सिमिलरली tan इनवर्स tan x का देखो क्या होगा. इसमें बस केयरफुल होना है डोमेन और रेंज को लेके, और किसी चीज को लेके नहीं. tan इनवर्स tan x का डोमेन, ये रेंज क्या होगा -π/2 से π/2. -π/2 और π/2 इंक्लूड होगा क्या, नहीं होगा. ऐसे ही चलता रहेगा विथ ओपन बॉल्स, राइट. इंटीग्रल मल्टीपल्स ऑफ π/2 पे के ओपन बॉल्स रहेगा. समझ में आ रहा है ये चीज, tan इनवर्स tan x भी समझ में आ गया. सिमिलरली cot इनवर्स cot x भी हो जाएगा. cot इनवर्स cot x कहां से कहां तक रहेगा, 0 से पाई है ना, कहां पे वो गायब हो जाएगा π/2 पे. तो मतलब वो कुछ ऐसा होगा, अगर मैं ऐसा होगा कुछ, है ना. क्लियर, कोई प्रॉब्लम नहीं है, दोनों ग्राफ समझ में आ गया. अब है मान लो साइन इनवर्स 2x अपॉन 1 प्लस क्या होता है, ये साइन 2 थीटा हो जाता है ना. x को क्या लिखना होता है, x को हम tan थीटा लिखते हैं, ये सब्स्टिट्यूशन करते हैं, राइट. फिर हम इसको लिखते हैं साइन इनवर्स साइन 2 थीटा. इसको सीधे 2 थीटा लिख सकते हैं क्या, नहीं. वी नो दिस इज माय साइन इनवर्स साइन थीटा. तो साइन इनवर्स साइन 2 थीटा क्या होगा, यही होगा, लेकिन ये पॉइंट क्या हो जाएगा π/4, ये π/2, और पाई पे रिपीट होने लगी कहानी, क्योंकि 2 थीटा का टाइम पीरियड क्या होगा पाई, ऐसा कुछ होगा. तो माइनस, तो यहां पे हम ब्रेक करेंगे कि -π/4 से π/4 है जब थीटा, तो क्या होगा साइन 2 थीटा इज इक्वल टू 2 थीटा. क्लियर, कोई इशू नहीं है. और जब -π/2 से -π/4 होगा तो क्या होगा, और जब π/4 से π/2 होगा तो क्या होगा. एक तो हो गया 2 थीटा, एक देखो क्या होगा, ये दिस इज नथिंग बट -2 थीटा, और ये पॉइंट क्या है माइनस पाई बाई 2। तो इंटरसेप्ट क्या हो गया? वेट वेट वेट, टू थीटा, आई नो दिस ग्राफ, दिस इज माइनस पाई बाई 2 है ना? क्लियर? दिस माइनस पाई बाई 2, so I know minus 2 theta plus c is equal to y, यही होता है ना? minus 2 y is equal to mx plus c, and we know y is 0 here at x intersect, so c turns out to be 2 theta, और थीटा क्या है? माइनस ये हो जाएगा इक्वेशन माइनस 2 थीटा माइनस पाई बाई 2, तो आई कैन से, है ना? सॉरी पाई होगा क्योंकि पाई बाई 2 ये हो जाएगा ना इंटरसेप्ट, है ना? और ये क्या हो जाएगा? माइनस 2 थीटा प्लस पाई। क्लियर? तो अब हमें ये निकाल दिया हमने, लेकिन 2 थीटा क्या है? 2 tan इनवर्स x, तो इसको रिप्लेस करेंगे हम 2 tan इनवर्स x, इसको रिप्लेस करेंगे माइनस 2 tan इनवर्स x, और इसको रिप्लेस करेंगे माइनस 2 tan इनवर्स x, और हमने ब्रांच कर दिया है माइनस पाई बाई 2 टू पाई बाई 4। हम ग्राफ जो बनाएंगे वो क्या होगा? माइनस 2 tan इनवर्स x माइनस पाई। तो इस ग्राफ को कैसे बनाओगे? यू नो द ट्रांसफॉर्मेशन। tan इनवर्स x का ग्राफ कैसा बनता है? कैसा होता है tan इनवर्स x का ग्राफ? ऐसा ना? ठीक है। और यू नो पाई बाई 4 पे क्या कहानी है, पाई बाई 4 के बाद क्या कहानी है? बस वही चीज यहां पे तुम बिल्ड करोगे, ड्रॉ करोगे। तो माइनस पाई बाई 4 से पाई बाई 4 तुम्हारा ग्राफ होगा 2 tan इनवर्स x का, मतलब ये वाला पार्ट ट्वाइस, मतलब स्क्वैश्ड। क्लियर? सॉरी ये पुल्ड अप। ठीक है। और जहां पे शिफ्ट करना है वहां पे शिफ्ट कर देंगे। x कहां से ले रहा है? x यहां से ले रहा है। अच्छा आप देखो x को भी यहां चेंज करना पड़ेगा, माइनस इंफिनिटी से माइनस, ठीक है। और x यहां से क्या हो जाएगा? -1 to 1, और ये क्या हो जाएगा? 1 to, तुम्हारा ग्राफ बन जाएगा। मतलब -1 से 1 के बीच में तुम्हें 2 tan इनवर्स x डालना है, माइनस इंफिनिटी से -1 के बीच में लिखना है -2 tan इनवर्स x माइनस पाई। यू नो हाउ टू ड्रॉ दिस। और 1 से इंफिनिटी के बीच लिखना है -2 tan इनवर्स x प्लस पाई। क्लियर? तो ग्राफ तुम्हारा ऐसा होगा। I know the graph of tan inverse x. It is nothing but, right, and at x is equal to 1, at x is equal to -1। ठीक है, ये तुम्हारा ग्राफ है। तो यहाँ पे मैं रेड से बना रहा हूँ ग्राफ, तुम्हारा फाइनल ग्राफ। x 1 से -1 के बीच में the graph would be twice, मतलब pi by 2 will turn out to be pi and minus pi। यहां तक ग्राफ ऐसा होगा। क्लियर? यहां तक ग्राफ ऐसा होगा। फिर उसके बाद माइनस कर जा रहा है ना, -2 tan इनवर्स x। टाइम है? तो आप उसको देख लेना। इट विल फाइनली, आप जब क्या कहते हैं 1 से इंफिनिटी के बीच की कहानी है -2 tan इनवर्स x, तो 2 tan इनवर्स x का रिफ्लेक्शन ऑन द दिस, और पाई अप, पाई अप। तो वैसे ही पुल अप होकर ऐसे की तरफ एसिम्प्टोट बनाएगा, और ये ऐसे की तरफ एसिम्प्टोट बनाएगा। क्लियर?
A very good morning to all of you. Today we are going to cover a topic called halogens and noble gases. You have so far covered all the P block elements along with the S block elements. This is a topic from inorganic chemistry where we will be covering and actually winding up with the P block elements, that is noble gas and the halogens. Halogens come first and then the noble gas. So let me take up the halogens first. Next slide, please. So from the halogen family, next slide. We all know that fluorine, chlorine, bromine, iodine, and astatine, these all actually combine as a halogen family. Halogen, they are named as because they are salt producers. They produce salt whenever they react with anything, most of the times. Next slide, please. And this is where we say that astatine is not very well known because chemistry of it is not very much well known to anybody. We do not know enough about their reactions. It's also radioactive. So the abundance is not also great enough on the earth crust. So basically when we call of halogens, we most of the times talks about fluorine, chlorine, bromine and iodine. Fine. Next slide, please. And all these are sp2p, you can say when the configuration comes up sp2p5 element, that means they are lacking just one electron to complete their octet. So if they take up one electron, they become absolutely full octet and then they need not to react. Because of the incomplete octet, you can say by one electron, they look forward for such reactions where they get one electron and the octet gets complete. Next slide. Now, halogens are the p block elements, and as we talked, next slide, where the only one electron is actually missing up. So that is why if we say that in a free elemental state, the octet should be completed by one electron. Next slide. So in that very case, they can gain electron by two methods. One is the ionic method, where they take up the electron completely from any of the alkali metals and there forms an ionic bond and the halide ion can be actually taken up because an excess of electron taken up from maybe any of the alkali will create a negative charge, so halide ion forms. Halide ion means any of the halogen with a negative sign. And other way around, they can do is they can share an electron. How they can do it? They can share it with a single unpaired p electron because they have one unpaired p electron in their p subshell. So they can share it with some other you can say element which has one unpaired electron, maybe the same halogen family only, and they form a covalent bond because it is because of the sharing of the electrons. One electron unpaired is being shared with the other unpaired electron. Both the atoms actually share, both of the, you can say, subshell get overlapped. So that is why it is a covalent bond. Next slide. Now, high electronegativity and electron affinity is seen among the same period. Period means this way. So if you get to see along this way, in all of the periods, the halogen family is the most highly electronegative because you know electronegative means that they need more or they abstract electrons very easily. Only one electron is required and have tendency to attract electrons. That's why they are called as strong oxidizing agents. Oxidizing agents means that they actually reduce something else. Fine. They reduce the other party and the oxidizing agents they are acting as. They reduce themselves and oxidize the other thing. They reduce themselves means the reduction happens in themselves. Reduction happens in themselves means reduction means they should take up an electron. As I have taught before also, oxidation and reduction is very easy to be understood and remember also. Both the reactions are actually dealing with the uptake or giving up of the electron. In oxidation, if I take up any of the, you can say, metal, it gives up the electron. Fine. However, in reduction, or you can say a metal with a minus sign, this kind of a reaction is observed. Why it is so? Because electron should be on the reactant side with reduction. Easy to memorize. R for reactant, R for reduction. So electron should come up in the reactant side. So in reduction, always electron is on the reactant side. And in halogens, because they are actually lacking one electron, they take up electron very easily. So this kind of reaction is more feasible. It's difficult to take out an electron and create an oxidation for any of the halogens. However, reduction is the most favorable condition for halogens because taking up an electron will complete their octet. Rather, going from NP5 to NP4 condition is not a great feasible reaction. They always prefer taking up an electron than giving it up. So performing this kind of a reaction is more, you can say, dominantly preferable. Fine. And that means reduction is more favorable. If reduction goes more favorable, they are the oxidizing agent. Oxidizing agent reduces itself and oxidizes the other. Agent means it brings out that mechanism. If it is oxidizing agent, it oxidizes the other things. Like LIC agent does not buy LIC or for itself. It provides LIC policies for others. So if it is an oxidizing agent, it will oxidize others. Fine. And if it oxidizes other, in lieu of that, it will reduce itself. Always remember this. If it goes with the reducing agent also, it goes that it can reduce rest of the things and it will oxidize itself. So as I told, previous slide please. As I told you here, that it is a strong oxidizing agent. Strong oxidizing agent because they have a tendency to accept an electron. That means they readily get reduced. If they get readily reduced, that means they are very well oxidizing agents. They can oxidize others at the expense of reducing itself. Clear? Next slide. So when it comes to the high electronegativity or electron affinity, the oxidation state, it actually acquires is -1. That's the most probable one. Though it may have many variable oxidation states, but the most probable one is the -1. -1 because if it takes up a -1 charge, the octet gets complete. So that is the most preferred. Most preferred does not mean that the only preferred. There are more variable oxidation states also possible. So the ionic bonds which can be formed with a -1 charge when it takes up an electron from sodium is NaF, NaCl, NaBr, Nai. And so is the covalent bond where the sharing happens. The same electron is being shared by both of the, you can say, atoms. Then HF, HCl, HBr, Hi. All these, you can say, compounds can be formed. Next slide. Next slide, please. So variable oxidation states can happen in all the halogens except fluorine. Why so? Because fluorine among the group, you can see it comes at the top. That means it is the smallest of all. Next comes chlorine. So another shell adds up. So it actually becomes larger in size. Bromine, another shell adds up. So further large size. And the size keeps on increasing. However, for fluorine, you can see that it's low lying energetically. One, it is very small in size. Being small in size, it becomes difficult to actually come up with any other oxidation state than -1 because it does not have a vacant d orbitals where the electrons can move out and we can have variable oxidation states. So except for fluorine, rest of the halogens have variable oxidation states. Else, -1 oxidation state exists for all of the halogens. Next slide, please. Here we'll get to see the oxidation states, various oxidation states. Now, here you get to see that for +1, -1 or 0, what happens? This is NS and this is NP. This is the normal ground state electronic configuration where P5 is there. Fine. So what happens when you provide some energy? The one of the electron may go and get settled in the d orbital. Since fluorine does not have any of the d orbitals, or you can say the subshell is absent in the fluorine because of the very small size, it does not extend to variable oxidation state of +1 or any other state. Fine. It only comes up with the -1 oxidation state. Although chlorine, bromine, iodine, all of them have d orbital, vacant d orbitals lying in between. So that is why they have an availability of the subshell where the electron can move around. Fine. if you want to vacate an electron, you need a space also. Where will it go for the variable oxidation state, right? So this is how you can say +3 oxidation state is formed. 1, 2, 3, right? 3 molecules, or you can say 3 oxidation states are formed, free vacant orbitals. Same goes for the +5. If energy is given, one more electron goes to the d orbital. So creating 3 half-filled p orbitals and 2 d orbitals. Similarly, some more energy is being provided, then s can also be made to go unpaired. And how this you see that 1, 2, 3, 4, 5, 6, 7. So it's wonderful to see that +7, +5, +3, +1, 0 and -1. All the variable oxidation states are possible for chlorine, bromine and iodine. Right? Hence, they can form multiple coordinating elements, compounds. Next slide. Here are a few examples. Like chlorine, you know that valency of any of the halogen would come up to be 7, 2 for S, 5 for P. So if we start counting the number of electrons or the lone pairs, 1, 2, 3, 4, 5, 6. The 7th one forms a bond leading to a +1 oxidation state. Here again, you get to see 1, 2, 3, 4, leading rise to 2 lone pairs. A pair of electron leads to a lone pair, right? So here we get to see the paired electrons are giving the lone pairs. 3 are left and double bond with oxygen, single bond here with oxygen, leading up to 3 +3 oxidation state, right? Okay, here similarly 1, 2. So our rest of the, you can say bond formations can take place with the valencies 5, 1, 2, 3, 4, 5. So +5 oxidation state. And similarly, +7 oxidation state with no lone pair or no free left electrons. Fine. So there are number of compounds possible for variable oxidation states where you can have the same chlorine and hydrogen oxygen with different compositions of acids. This is HOCl, this is HClO2, HClO3, HClO4, varying with the oxidation number. Fine. These are all acids. Next slide, please. Now, various oxidation states of halogens and their ions, you can get to see that fluorine molecules only exist in the -1. You hardly see any of them. This is F2, which is a of 0 oxidation state because of the covalent bonding. Fluorine actually gets, you can say, share the electron with itself and forms a 0 oxidation state. Rest, nowhere else you will find any fluorine compound. But rest of the oxidation states are being favored for various substances and various compounds where further oxyacids are actually being formed. This is for +4, +5, +6, +7. So variable oxidation states, because there are more number of, you can say, electrons putting up, which can be actually moved to the higher d electrons or your d subshell. In that very case, we can have till +7, because 7 is the maximum number of electrons putting up in the NS2 NP5 kind of a system. So we have the maximum of +7 oxidation state. Next slide. Fluorine has -1 only as an oxidation state and no other oxidation state, because the most electronegative element and one unpaired p electron available for bonding. So it has -1, right? Next slide. It cannot expand its, you can say, octet because of the low-lying empty d orbitals are absent there. There is no d orbitals. And along with energy required to promote electrons in the third quantum shell is very high. Since it's very small in size. Small in size means that the subshell where the 5 electrons in the p subshell is very close to the nucleus. The smaller size means the same, right? So there is a considerable nuclear, you can say, attraction towards the electron, and they are not allowed to move outside to any of the, or get excited to any of the higher subshells. Fine. So that is why the smaller size, like for example, for fluorine, what happens? This is S, 2 electrons are there. If this is P, however, for chlorine, many more subshells comes up, and then comes this kind of electronic configuration comes up. Some more inner, you can say, electrons are filling in, and then comes the outer electron, the outer valence shells. So in doing so, this nucleus actually attracts these electrons very tightly, bind it very tightly, and does not allow them to move out on excitation or providing any kind of energy. However, the distance of separation becomes larger for chlorine, fluorine, and bromine because of the bigger size. Inner lying filled orbitals actually kind of screen them from the nuclear attraction, and because of which now they are free to move, so they can move also. The non-availability of d electron is one of the reason. The other reason is they are very close to the nucleus, so the nuclear attraction does not allow them to move out as well. However, they are being screened. Screen means cover, or you can say they are being spared or saved by the inner lying electrons. The force of the nucleus is more dominant towards the inside of the shell, subshells. As it goes outer, thus you can say attractive force becomes weak. So that is why they are more probable or preferred to move to the next orbital while providing the excitation energy. So that is also one of the great reason that fluorine cannot have any variable oxidation state apart from 0 or maybe -1. However, chlorine, bromine, iodine may have up till +7. Fine. Next slide, please. Now, the next point which comes up is about the melting and the boiling point. Melting and boiling point increases as we go down the group. As you get to see that melting point is also increasing and the boiling point is also increasing as we are going down the group. Next slide, please. Now, what is the reason behind that? As we go down the group, you get to see that the melting and boiling point both are increases. It's because the molecular size also increases down the group. Fine. What happens during a melting or a boiling condition? It says that electron cloud is more easily polarized. Polarized means it is actually among the whole of the polarity is being created. Fine. Induced dipoles are formed more easily. Fine. And because of it, stronger London dispersion forces act upon. So because of which, as the size increases, the melting and boiling point also increases. Fine. Next slide. Now, the another property, we are talking about the physical properties of halogen. We need to talk about the color becomes darker down the group. When you get to see fluorine as a gas, or you can say chlorine, bromine, iodine, these all are colored compounds. So pale yellow color for fluorine, greenish yellow for chlorine, reddish brown for bromine, and iodine becomes violet black. So as we move from top to bottom of the group, the color intensifies. Fine. Next slide. Here you get to see in pure form, these are the color formations. In water, it gives this color. Water being, you can say, non-polar compound, this kind of coloration is given. And polar solvent like 1,1,1 trichloroethane, some other color is found. So every time, if it is a polar compound or a non-polar compound in which the halogen is dissolved, it gives a specific color, a different color. Right? It's for the same iodine, it's violet black when it is in its pure state. It's yellow only and slightly soluble in water. However, it's violet for 1,1,1 trichloroethane. Right? So color keeps on changing depending upon the solvent it is dissolved in. Now, color, why it actually gives color? Halogen. Because it is non-polar molecule. Right? That is the reason it does not dissolve well in polar, you can say non-polar molecules are there. So it's not very soluble in polar solvents such as water. Itself being non-polar means there is no polarity between them. So what happens? It does not dissolve very well with the polar solvents. Water being inorganic has a polarity. It has a lone pair at one end and the bond pairs at the other. So it has a polarity. So it does not dissolve very well with, you can say, polar solvents like water, because the universal rule is like dissolves like. Polar will dissolve polar, non-polar will dissolve non-polar. Polar means being mixing up, or dissolving means mixing up, getting comfortable with each other, like you guys become comfortable with your kind of persons and don't get very comfortable with different kind of people. So polar is one class of people, non-polar is one class of people. So all polar molecules will actually dissolve very well, fine. Like you will get to mix or solubilize. Mixing is solubilizing. Solubilizing means the mixing only. When you solubilize sugar in water, that means you mix it. And it should be actually one. Fine. So in that very case, we get to gel with those who are like us only. With different people, we don't gel well. Fine. Attraction is something else. But mixing means solubility. Always remember. So solubility comes up with the same kind of people or same kind of molecules. So polar will dissolve polar, non-polar will dissolve non-polar. But polar and non-polar won't dissolve very well. Fine. So halogens being non-polar molecules, they are not very soluble in polar molecules. However, in organic layers, they are very soluble because most of the organic molecules are non-polar. Because of the carbon moiety, polarity is not generated. Polarity generates in ionic substances. So it comes up in the inorganic species. Right? Next. Like you get to see the colors of halogens in water. Chlorine, bromine and iodine, they all have some colors. Here it is chlorine, this is bromine and this is iodine. Different color formations comes up because of the difference in the solubility as well. Fine. Next slide please. And trichloroethane, 111 trichloroethane, it gives different colors. Iodine wasn't giving the violet color when it was dissolved in water. Rather, the solubility was also to a very less extent. Next slide. Now, electron affinity. Electron affinity, what does it mean? First of all, we need to see that electron affinity is following a trend. Trend where fluorine, chlorine, bromine, iodine along going down the group, chlorine onwards, it's actually decreasing. Fine. And it's maximum for chlorine. And for fluorine also, it's decreasing. Rather, going in the same side, it should be highest for fluorine, but it is not so. Why so? Next slide. The number of electron shells and size of electron of the atom increases down the group. That's very true. But the nuclear attraction for the additional electron decreases down the group. Nuclear attraction, as I told you when I made this diagram, I told you guys that as the screening molecules or electrons come in between, they actually here you can see in fluorine molecule, since the nuclear attraction is very dominant for the unpaired electrons outside also, being in the close proximity. However, for chlorine, bromine and iodine, the attraction becomes lesser. So affinity for next electron should actually be like electron affinity should decrease from chlorine to iodine, because whether the octet gets complete here or not, it's okay for it. Fine. Electron affinity means that the octet should get complete. Does not really matter as long as the shell goes on farther and farther from the nucleus. However, the trend does not follow for fluorine. It should have been highest for the fluorine, but it's not so, because if I need to accommodate one more electron over here in this very subshell, being the smallest in size and already accommodating 5 electrons, will actually create a kind of a crowding. So because of which it will experience an repulsion from all the neighboring electron as well. So only in the case of fluorine, the electron affinity lowers. However, the trend should be that the electron affinity should decrease down the group, because as it goes on farther and farther from the nucleus, the need of an extra electron to become equivalent to the nuclear and the electronic charge reduces because it is far enough. But the trend is not the same for fluorine only. Fluorine does not have the highest electron affinity only for the reason of the very small size that incoming electron will experience an electronic repulsion from the neighboring, you can say, small size shell putting up with 5 electrons. So that is the reason the trend goes like for electron affinity, that the electron affinity is maximum for chlorine and it goes decreasing down the group. But only exception comes up with fluorine, which is not at the highest electron affinity because of the small size, and the smallest subshell putting up already 5 electrons does not allow an extra incoming electron or does not welcome with that great power because there is already a crowding. Small subshell already putting up with 5 electrons. These are the bigger subshells. The outer electrons being putting up in chlorine, bromine and iodine are the bigger subshells. So the electrons putting up already have enough space. However, fluorine being smaller in size, already accommodating 5 electrons in the outermost one, does not actually really appreciate coming up of the next electron. Already they are overly crowded. So it's only with the fluorine that the trend takes a reverse order, and chlorine becomes the highest in the case of electron affinity. Fine. Electron affinity, the term itself is the affinity for an extra electron coming up. So it should be maximum for the fluorine, but it is not so. So it goes for the chlorine, the maximum. Clear? Next slide, please. Now, the atoms of fluorine have smallest size and the same interpretation has been given. So fluorine has the lower electron affinity than chlorine and bromine. Right? Next slide. Next property is electronegativity. Electronegativity means the term that electronegativity, that it has a tendency to accept the electron. Fine. The tendency though goes this way. Next slide, please. Where the number of electron cells and size of an atom increases down the group. So electronegativity decreases down the group. Most should be for the fluorine as the trend was actually expected. The nuclear attraction for the bonding electron decreases down the group. Fine. Because it is not about accommodating an electron itself, it is about forming a bond with an electron. So now fluorine does not have any problem because it does not need to actually accommodate in the subshell, rather needs to bond and have an electron, getting an octet complete. So it will have a high electronegativity, unlike the electron affinity trend. Electronegativity and electron affinity are two different things. Fine, getting it? So it need not to accommodate in its own subshell, but only to bond with an electron. So bonding with an electron, the electronegativity is quite high for fluorine because it does not need to accommodate in the same subshell. Clear? So the trend remains the same as it goes down the group, it decreases, and it is maximum for fluorine for electronegativity. Clear? Next slide. Fluorine has the highest electronegativity because it is most reactive element. So that is also very clear that as we go down the group, the reactivity decreases. Reactivity decreases because as they go farther from the nucleus, as you get to see that they are not reactive, they are not actually very much dependent that they need to react with a molecule and complete their octet and become equivalent to the charge of the nucleus. Fine, the nuclear and you can say octet charge should get completed, or the octet should get complete. So they become less reactive as the size increases. Fine, you can actually understand by the concept that you tend to find all those thin people are more active according to the social, or you can say the mental state, that you find that as the size actually increases, people tend to become less active. They are very lethargic, they are not very active enough. So is with the, you can say, periodic table also in halogen family. As the size increases, you go down the group, activity or reactivity decreases. So in a group, the most reactive element is going to be the topmost one, the one which comes the first. So fluorine is the most reactive among all. Next slide, please. Now, let's come up with some of the questions. Because of no animation coming up, answer is still marked here. So let's see, how many electrons do the halogens have in their outer shell? It's 5 outer shell, because 2 in S and thereafter 5 in P. So outer shell is the P, so it will be 5. Fine. Next slide. You don't need to mark 7. Please, previous slide, please. Many times what happens, students make a mistake and they mark 7. 7 is the valency, does not mean, because you have to be very precise in your JEE exams that what has been asked. Halogens have in their outer shell. S is not the outer shell. The outermost shell comes up as P. So you need to mark 5. Both the options are given. Many of the students may be marking 7, but that is an incorrect answer, because 7 is not the outer shell. P is a subshell, but they are asking about outer shell, no? That's true, but subshell and shell is taken up as same. But it is not taken as the valency. If would had been asked as valency, then it had been a 7. Fine. Next slide, please. How many atoms exist in halogen molecules? How many atoms exist in halogen molecules? This answer is not marked correctly. It should be 2. Fine, because they can form covalent bond in a molecule, and there can be Cl2, Br2, all those kinds of elements. Next one. What is the order of increasing reactivity of the halogens? This is also marked, it has to be marked here at the option B, because you know as we go down the group, the reactivity decreases. The smaller the size, more active, or you can say more reactive molecule is going to be. Fine, next slide. Here we see the chemical properties. The reactivity is most for fluorine, thereafter chlorine, bromine and iodine. React by gaining electrons. Fine. That is why I told you they have a very good oxidizing power. Oxidizing power, oxidizing agent. Because they reduce themselves and oxidizes other. At the expense of it only it happens. Because of which, so the oxidizing power would be at the same level as the reactivity goes. If we say which one is the most oxidizing agent, the better oxidizing agent would be the most reactive among the all, because they all are oxidizing agent. Fine. Halogens, all the halogens are good oxidizing agents. Fluorine molecule, chlorine molecule, bromine, iodine, all the molecules are oxidizing agents. But if we need to rank them, then their ranking comes up as their reactivity comes up. The more the reactive, more the oxidizing agent. Fine. So the oxidizing power or the oxidizing agent actually comes up as fluorine as the maximum and iodine as the least. Fine. Because of its reactivity series. Clear? Next slide. Now, reaction with sodium. As the reactivity goes, fluorine will actually react readily, or you can say the violently of the all, and iodine will react the least among the group with sodium. Though sodium is very favorable to be reacted because sodium has 1 extra electron and halogens have 1 less electron. So that kind of interaction is very favorable to form an ionic bond and have a full octet for both of them. Fine. But among the group, you will get to see that fluorine reacts the most and iodine the least. Though all will react to complete their octet, but comparative study will show that fluorine is the most reactive and least is the iodine. Next. Now reactions with hydrogen. Same as you get to see with the hydrogen also, fluorine reacts most explosively. Explosively means very fast and very, you can say preferably. Fine. And iodine reacts slowly and reversibly even on heating. You need to provide some energy to actually let it get reacted with the hydrogen. Fine. So the reactivity goes down as we go down the group. Next. Reaction with phosphorus also you get to see, like fluorine molecule is the strongest oxidizing agent. If something is a good oxidizing agent, that means it will oxidize the other molecule or the compound it is reacting with to the maximum of the oxidation state. It will oxidize completely. Now phosphorus has oxidation state as +3 and +5. We all know that very well. In nitrogen family, we have studied this. So it will get completely, or you can say the maximum oxidation will happen with the very good oxidizing agent, and it will go to the maximum oxidation state with the best of the oxidizing agent. Since fluorine is the strongest oxidizing agent among the whole of the group, it is going to the maximum oxidation state, that is PF5. Fine. And as we go down the group, it goes to the lower oxidation states. It won't form PI5 with iodine because it is an oxidizing agent. It will oxidize phosphorus, but not to that great extent as fluorine will. Fine. The extent will different. It will readily oxidize with iodine as well, but the extent will be less. So because of which it will go to the lower oxidizing state. Next slide, please. Yeah, here you can see that bromine and iodine are not strong oxidizing enough, so it is not going to the highest possible oxidation state. Next slide. Reactions with xenon and carbon. Xenon and carbon, you get to see that fluorine reacts directly with all non-metals except nitrogen, helium, neon and argon. They do not actually react readily with them, but it will even react with diamond and xenon on heating. Fluorine is so reactive that actually we will talk about xenon in detail when we'll talk about the noble gases. Actually, xenon is a noble gas, but it comes down the group. So here what happens, the trend goes differently, that because noble gases are not reactive at all. So the you can say being inert, as we go down the group, goes down. So it starts reacting somewhere or the other. Fine. So carbon and fluorine also gets reaction. That means with the diamond. And with xenon also, it forms multiple oxidation states and gets you different compounds. Fine. Next slide, please. Reaction with xenon. Xenon can expand its octet by utilizing vacant it has d orbitals in between. So what happens, though it's a noble gas, an inert element, but because it is very far off from the nucleus size, or you can say the size is very big, so being inert also reduces. Whatever property is there will reduce as we go down the group. So halogens being reactive molecules, it reduces reactivity, reduces down the group. And noble gases being inert, the inertness reduces down the group. Fine. So xenon comes very down the group. So the you can say inertness actually reduces to an extent, and you can see that xenon has vacant d orbitals. So this is the complete octet for xenon, and this is for fluorine. 1 electron is less for fluorine. Octet is complete for xenon, being inert gas. Fine. What happens if we provide some energy to that? 1 electron can go to this of the 5d, next slide, and it can accommodate 2 fluorine molecules with it. Another variable oxidation state, if further energy is provided, 1 more electron from this side will go to D. And now 4 fluorine molecules can accommodate with them. Fine, because fluorine is only 1 electron. So sharing of 4 fluorine molecules can take place and forming XeF4. Fine, next slide please. Or you can say here 1 more electron is being expanded to this side. It can accommodate 1, 2, 3, 4, 5, 6. So 6 fluorine molecules can be, 6 fluorine atoms can be accommodated, forming XeF6. Next slide please. And reaction with xenon actually can happen only because gap between NP and ND subshell goes down the group. Like that as I told you, that whatever is the main or dominant phenomena of that very group, as we go down the group, because of this increase in size, that very property decreases. Fine. So the promotion of electron from NP subshell to ND subshell becomes easier down the group, because nucleus does not have that good effect or impact on the outermost shell as we go down the group. So now they can move out here or in wherever. If you say that nucleus is a kind of a teacher or a principal, as further the class or the subshell goes, the impact or the effect of nucleus reduces. Fine. So because of which, if they were inert because the octet was complete, now they are free to move and become reactive. If they were reactive, they are actually, they can be lazy and they may not react. If they are farther from the, you can say, the main authority or the principal or whatever, whosoever is actually judging them all. Fine. Understanding this very aspect, you will get to know the concept. Next slide, please. So it goes like this for xenon, and we can have XeF6 kind of a structure. Energy released by forming more single bonds overweighs the energy required for promoting 5p electron. That means that in xenon, the energy provided from xenon to the excited xenon to travel these molecules to the d electron is lesser than the energy which actually forms the bonds of fluorine with them. So it already accommodates. ज्यादा एनर्जी मिल रही है फ्लोरीन के साथ एटम बनाने में देन इन इलेक्ट्रॉन्स को डी ऑर्बिटल्स तक फैलाने में, तो वो जो है कॉम्पनसेट कर देती है उस एनर्जी के लिए. तो इस तरह की इलेक्ट्रॉनिक स्टेट इज वेरी फिजिबल. फाइन. That means this kind of electronic state is more feasible because of the movement of these electrons to the d electrons. Right? Next slide. Now reaction with other reducing agents. What happens with the reducing agent, because halogens are the oxidizing agents. Iodine is the weakest oxidizing agent among the halogens, as we all know, because halogens are the oxidizing agents. They actually tend to reduce themselves by taking up an electron. So all the halogens are oxidizing agent. Fine. However, the oxidizing agent or the activity of oxidizing decreases down the group. So iodine is the least or the weakest of the oxidizing agent. Fine. Next. So if we get to see that all halogens oxidize Fe2 to Fe3 plus. Ferric to ferrous is being oxidized. Who oxidizes them? Any of the halogen can, right? So you get to see that all are oxidizing agent, but iodine does not have good enough oxidizing potential, you can say, to oxidize iron, that is ferrous to ferric to ferrous. Fine. You get to see here that chlorine, bromine, and even fluorine can oxidize ferric to ferrous, but iron cannot. Iodine cannot. Right? Though it's an oxidizing agent, but the oxidation, the standard electrode potential lies above that of the iodine. You must have studied in your electrochemistry. You have studied your electrochemistry. You get to see the feasibility of the reaction comes up if E naught is positive. Fine. Delta G should be negative for a spontaneous reaction, and delta E, because delta G is equal to minus NF E naught. So E naught should be positive, other way around. Fine. So E naught should be positive means if both the reactions are this way, this is not possible. If this is to be reduced, this is to be oxidized, the reaction is to be inverted. Inverting this reaction will vary the sign. It will become minus. If I add these two, the magnitude will be negative. That means E naught will be negative. So this is not a spontaneous, or you can say a feasible reaction. Fine. So iodine won't oxidize ferric to ferrous. Although if I invert this, this will be minus. If I add these two, plus 1.07 and minus 0.077 will in turn get me any E naught value as positive. And so for the above, any of them. So these reactions are feasible. However, iodine cannot oxidize ferric to ferrous. This may be asked in your JEE exams as an MCQ. Fine. Next slide, please. All halogens except iodine oxidize S2O3 to SO4 minus sulfate. Fine. Thiosulfate to sulfate. Chlorine, fluorine, bromine. All of them bring out this kind of an oxidation. But iodine does not. And this application is being used for the iodometric titration, because thiosulfate is not reduced to sulfate ions. Rather, they are reduced to some other form which imparts color. and then we can get an iodometric titration. This is the application of an iodometric titration, that it's only iodine which, being an oxidizing agent, cannot oxidize thiosulfate. That is why thiosulfate to sulfate, that is why it is being used in iodometric titrations. Fine. Next slide, please. Now, displacement reactions. You all know that displacement reactions in normal terms get to say that if there are two places or vacant seats putting up, already two people are sitting over there. Now, they can be displaced only when a stronger person comes in or more reactive person comes in. Then only the less reactive will actually accommodate the stronger and will get displaced by the stronger one. So this is the whole concept of displacement reaction. As we know that moving down the group, the reactivity decreases. Fluorine is most reactive, thereafter chlorine, then bromine and iodine. So the more reactive will displace the less reactive ones. That's the whole concept of the displacement reaction. That means if you get to see that chlorine is sitting idle, however bromine is sitting as ion. It could be NaBr, it could be KBr, any of the molecule, fine. So chlorine will come and make a reaction visible with the ion form, and bromine will come up as bromine molecule. You can say the more reactive will displace the less reactive in the reaction. Fine. So the displacement reaction goes like this. That means all the halogens, iodine, bromine, chlorine, all of them can be displaced by fluorine because that's the most reactive. Chlorine can displace bromine and iodine. However, chlorine cannot displace fluorine because fluorine is itself more reactive than chlorine. Fine. So is the case with bromine. It can displace iodine, but it won't displace chlorine and fluorine. Fine. And iodine cannot displace anything. Clear? Next slide, please. Here is the reaction summary of all. Because fluorine won't displace fluorine, so there is no reaction. But no reaction will take place for chlorine, bromine and iodine also, because fluorine cannot be displaced by anything. It's the most reactive. Fine. However, with chlorine, fluorine will displace it, giving a pale yellow solution formed by the chlorine molecules. Chlorine gas being released will form a pale yellow solution. Fine. However, there won't be any reaction for rest of them because they are less reactive than you can say chlorine, so they won't displace them. Next slide. So is the case with bromine. Bromine will be replaced by fluorine, will be replaced by chlorine, but there won't be any reaction with iodine. And there won't be any, you can say with iodine, in the case of iodine, all of them can replace iodine except iodine itself. Fine. Next slide. Next slide, please. So here comes the question, that which of the pair of reactants will not result in displacement reaction? Bromine and sodium iodide. Sodium iodide will get displaced by bromine because bromine comes above that. Chlorine and sodium iodide. Again, iodine can be displaced by either of them. So again, it will get displaced. Fluorine and sodium chloride, because fluorine is above chlorine, so it will displace it. The only option left is iodine and sodium chloride. Iodine won't displace anything. Fine, so this is the option. But you need to be very sure while reading out a question whether it is the pair of reactant which will not result. Here I have marked not in orange, but in your question papers many a times what you make a mistake that you do not read the question clearly, whether it is asked for an opposite option or the other way around. Right? Most probably you will find that rest of the three options are coming up in accordance with the one. Fine. But that three options will be displacing, won't be displacing, and one won't be. But it won't be true always. So please read the questions very carefully. Next slide. Now, disproportionate reaction. Proportionation reaction is a chemical change where the oxidation and reduction happens at the same species. Though in redox reactions, what happens? That the oxidation and reduction happens simultaneously but on the other species at the expense of each other. Fine. A oxidizes to A plus, but B minus reduces to B. This is what happens. However, in disproportionation reaction, the same species gets oxidized and reduced at the same time. Right? How? We can see. Next slide. Here is a reaction. This is a very peculiar reaction, very frequently asked in JEE exams. I guess last year also there was a question in 2015 that chlorine water, what happens to the chlorine water on standing? Now you can see that water, reaction with water and chlorine, you must have come across that many a times the MCD water or Delhi Jal Board water is being treated with chlorine. Many a times the advertisement comes up in Doordarshan and they say that put a chlorine tablet in a water of a 1 liter or a 1,000 liter jar, and that will actually clear the impurities or any kind of a bacteria and all that. So what happens and how it actually goes on? Now look at the reaction. Chlorine with water forms HCl and HOCl. HOCl is chloric acid. One is marked for fine. Chloric acid is being formed along with HCl. How? The chlorine water gives you HCl and chloric acid. Next slide. So the chlorate ion, that is the chloric acid, HOCl, is known as the hypochlorite ion. This is a very unstable. Although in the presence of sunlight, or you can say when the temperature is increased, it actually decomposes to form HCl and oxygen. It gives oxygen back again. Fine. But next slide, please. What happens when there are already impurities putting up? There is a closed jar where no sunlight, no increase in temperature is provided. What happens to the dyes or kind of impurities? You get to see many a times you put a chlorine tablet to a colored or a dirty water. When you filter it up, because the impurities will settle down at the bottom, when you filter it up, you get a clear water. How it happens? Because you can say when chlorine and water was actually reacting, they form HCl and HOCl. However, HCl remained there only, but HOCl combined with the colored dye, or you can say the impurity which is imparting color to the water, and then it oxidizes the dye, because chlorine is an oxidizing agent, right? So it oxidizes the dye, and addition of oxygen in the dye happens and the color oxidizes. As the color oxidizes, the color flows off, right? It goes off. So is the impurity, and chlorine in the form of HCl remained behind. Fine. So if a question is asked that what happens to a chlorinated water while being like whose color changes, what remains behind? So obviously, if you need to be very cautious while reading out the question, whether the question demands what is it is demanding upon, whether it is demanding upon it is a chlorine water, what it gives. Chlorine water will give HOCl and HCl. But if it says that on standing or under the sunlight, what it gives, because previous slide please, because we have already seen, previous slide please, we have seen that it's very unstable. HOCl is very unstable. So under sunlight or high temperature, it reaches out to give HCl. Fine. So in that condition, you should write only HCl. Fine. And if the question is asked that chlorine water in presence of a dye or a colored chemical which actually diminishes the color, what should be left behind? Next slide. Again, it will give you only HCl. Previous slide, please. Once only. Yeah, HCl. Because HOCl will oxidize the dye to convert to HCl. So you have to be very clear that what they are asking, at which stage they are asking that chlorine water is producing what. If it is a simple chlorine water, it is going to give you HCl and HOCl combination. If it is kept on standing under a sunlight or increased temperature, it will only give you HCl, because HOCl will decompose or will get unstable. HOCl will transform to HCl. If there is a dye or an impurity which has been actually settled to a color, has been actually diminished because of the chlorine water, again there will be HCl only, because HOCl has oxidized the dye and have in turn converted to HCl. Fine. So you need to understand at what stage they are asking the formations of the chlorine water. Clear? Next slide please. Now reaction with water. Because chlorine water question was already there in the last year JE exam, so I just discussed in brief. Reaction with water for bromine is also the same way, but obviously the reactivity goes on decreasing as we go down the group. Though it actually acts just same as chlorine. It forms HBr and HOBr, but to a lesser extent because only slightly soluble in water. Not that greatly as chlorine is because the reactivity is decreasing down the group. So mainly exist as molecules in saturated bromine water. So reaction with water on hydrolysis takes place and you can see here HBr and HOBr same as in the case of chlorine is being formed. Next slide. And similarly here also HOBr is unstable and it can bleach a dye or any of the impurity the similar way chlorine does. Fine. But we do not use bromine tablets. Rather, we are more prone to use chlorine tablets because bromine is less soluble. The solubility is less. So the cleaning effect is also less in comparison to the chlorine. Chlorine is more efficient. Fine. Next slide, please. However, iodine does not react with water. It's slightly soluble. So iodine won't create any kind of a cleaning or you can say imparting any oxidation to the impurity or the dye. So that kind of property is not governed by iodine. So we do not use any iodine, you can say iodine capsules for cleaning water. Next. However, fluorine. What about the fluorine, the most reactive ones? It reacts vigorously with water to form hydrogen fluoride and oxygen. Now, here is a very different story. It's not at all like forming HCl and HOCl or HBr and HOBr in case of chlorine and bromine. What happens here is, it is rather forming HF and oxygen. It is behaving differently with water as in case of chlorine and bromine, though iodine is not at all reacting with water. Fine. It is so reactive that being so strong oxidizing agent, fluorine undergoes reduction rather than the disproportionation with water. It itself undergoes reduction because I told you that it is the strong oxidizing agent. So it will perform a kind of an oxidation to the highest oxidation level. Right? So because of which it won't form HOF. Okay? It won't form HOF, rather oxygen will be formed. The highest oxidation state will be achieved. Fine. So this proportionation with water won't happen here. Fine. Next slide, please. You get to see here that reaction with water, chlorine reacts similarly at high temperatures. High temperature, I told you, or exposed to light because HOCl is not stable, fine, under sunlight or high temperature. It decomposes to HCl. So in turn, you get this kind of a reaction. Pure HCl is being formed. So you need to understand that chlorine water decomposes to what? You understand the three stages. If it is only a reaction, what chlorine water consisting of, then it contains HCl and HOCl. So is with the bromine, right? But if it is kept under the sunlight or it under the elevated temperatures, the temperature has been raised, then it is going to give you HCl because the HOCl in turn produced will convert to HCl. So it will be only HCl, right? And in the third case, if we say there was a dye which was imparting color, now there is no color. That means the color impartation must have been taken care well with the HOCl and that has been already converted to HCl. So now my chlorine water will contain only HCl. Clear? Next slide. Anomalous behavior of hydrogen fluoride. Now, hydrogen fluoride has a very anomalous behavior than the rest of the HCl, HBr and HI. How it is so? Because it has the highest boiling point and the melting point is also highest among the group. Fine. However, the trend was different for the, you can say, halogens. But hydrogen fluoride has the highest of the all boiling points. Next slide, please. Now, this is because of the bonding, the hydrogen bonding taking place between them. Why? Because so if I need to boil such an, you can say, compound which is actually having a branch chain kind of a structure where the weak bonding is happening, the hydrogen bonding is taking place, that means I need to actually break these bonds. Breaking these bonds will require more of energy, more of temperature will be required to bring about the boiling point, right? So there is a different, or you can say an anomalous behavior for hydrogen fluoride only, because the hydrogen bonding takes place. Why hydrogen bonding takes place for the fluorine only, not with chlorine, bromine or iodine? Because fluorine has a almost the same size that of the hydrogen. So the bonding, or you can say the mixing, or you can say the friendship among them is very well as compared to the chlorine, bromine and iodine. The size becomes larger in comparison to the hydrogen. Fine. So the more the better the bonding, the hydrogen bonding. If I need to have a boiling point, I need to break these bonds as well. In breaking these bonds, I need more, require more energy, or you can say the more temperature. More temperature means higher boiling point. The more boiling point will shift to the higher value. Only for the HF. Next slide, please. Now, acidic properties of hydrogen fluoride. Now you know that hydrogen and fluorine form very good bond. And there are hydrogen bonding among the intermolecular forces also. Like intermolecular hydrogen fluoride, there is a hydrogen bonding. One HF forms a hydrogen bond with other HF. So there is a good, you can say, bonding among them. Acidic strength means, what is an acid? What does acid means? Something which deprotonates or gives up an hydrogen is a good acid. The more the tendency of giving up an hydrogen, the more better acid it is. Fine. If hydrogen fluoride is forming a very good bond with hydrogen, the fluorine is finding very good bonding with hydrogen. It won't give up hydrogen very easily. That means the acidic strength will be the least. It will be the least acidic. Being acidic means it should give away hydrogen. Fine. And as we go down the group, the bigger size iodine will have least bonding with the hydrogen. So it will have the greatest tendency to give away the hydrogen very well. In that case, Hi is the having the greatest acidic strength. And the other way around, this time, the acidic strength increases down the group. Fine. Because it is about giving away the hydrogen. Since HF is very well bonded with hydrogen all the time, it won't allow hydrogen to go away and give an acidic kind of a nature. However, iodine not getting very well because of its very big sizes compared to the hydrogen, they do not bond very well. So because of which it gives away hydrogen very easily, or you can say very at great good condition. So in that very case, it is having a good acidic, or you can say it's a good acid. Here you can see the acid dissociation constants are of great difference also. Fine. So that means the degree of dissociation is so less for HF and so high for HI. Fine. So the acid strength increases down the group. Something increases down the group rather. Next slide. That is the acid strength. Now this is the lab preparation of halogens. This is how the halogen can be prepared. However, fluorine cannot be prepared this way. This preparation comes up for all the halogens except for fluorine. Fine. So what happens in this? You can see here in this chamber where we start up is. Here we are performing preparation for a chlorine. So we have taken NaCl. If we need to prepare bromine, we need to take NaBr. If we need to take iodine or prepare iodine, we need to take NaI or any of the alkali halide. Whichever halide halogen I want to prepare, that alkali halide I need to take. Fine. Along with MnO2. If I heat providing H2SO4 to the same, what will happen? Some gas will pass through here and will settle up in water. And then I let it allow to move through concentrated sulfuric acid, and which allows the chlorine. Now this is very easy to see and understand, but what are the chemical reactions undergoing this kind of a lab apparatus? Let's see. Now, when NaCl MnO2 was taken in this chamber and HCl was allowed to actually pass in this very chamber, what happened? Na2SO4 and MnSO4 formed, right? Along with H2O and chlorine. As this whole of these, you can see then water and chlorine, all these were actually made to move to next chamber. And to remove HCl, water was used. Fine. And from here, it was allowed to move to the chamber consisting of concentrated sulfuric acid. And then, free from HCl and water, chlorine was trapped. What happens if I do not take up MnO2? If I would not have taken MnO2, what would have happened? My reaction would have given me NaCl and H2SO4. NaCl and H2SO4 from here. Then I would have got HCl and NaHSO4. I would not have got Cl2. I would have got an acid. So how an HCl can be prepared? I can react one of the, you can say, alkali halide, that is chloride in the form of chloride, should be reacted with H2SO4 and HCl will be formed. Fine. Next slide. Now, interhalogen compounds. Interhalogen compounds are the compounds formed with the different halogens. These are the compounds containing two or more halogens. There are different halogens combining covalently, because you know halogens are having 5 electrons in their outermost octet, so they cannot form the ionic bond with another halogen. For ionic bond formation, they need any of the metals, that means alkali metals, alkali earth metals or anything, fine. But if they are forming interhalogen compounds, that means they are reacting with some other halogen compounds, there is going to be a sharing kind of a bonding, and that means a covalent bond is going to come. So that's why these are the covalent compounds. Clear? Okay. Now these are generally more reactive than the component halogens. If we say the reactivity is the maximum, if we have a kind of a question where chlorine, fluorine, bromine, and some interhalogen compound is also mentioned, which is the most reactive. So we should always mark that it is the interhalogen which is more reactive even than the fluorine. Why it is so? Because they are actually having the weak covalent bond among them. Being reactive means ready to react. They never react in the molecular state. They always react in the ionic form. When the covalent bond is weakest in them, what happens? It readily dissociates and actually reacts very well. So the interhalogen compounds are more reactive than the component halogens even. Fine? Due to the weakness of covalent bond between dissimilar halogen atoms. So you get to see different interhalogen compounds. Let's come up with the diagram, or you can say the structure of interhalogen compounds. Since these are in your course, if we get to see the interhalogen compounds, ClF3. If I draw a structure for ClF3, now there is chlorine with 7 electrons in its outermost orbit, or valency is 7. In that very case, 3 fluorine molecules should be accommodating here. 1 electron for all of them from chlorine and 1 from fluorine is forming a covalent bond. Now, chlorine is having 7 electrons in total. 3 are accommodating with the bond pair of fluorine. How many are left? 4. 4 in turn will form 2 lone pairs. This is for ClF3. A T kind of a shape. T shape or T structure for ClF3. Fine. The next example we have IF5. So the main halogen is iodine. Again, the valency goes 7. 5 goes for the fluorine. Now it is left with 1 more fluorine, 1 towards you above the blackboard. The fluorine is here, that means, and there remains two electrons which will be taken up as one lone pair, which will be behind the whiteboard. Fine. Now, what kind of geometry it has? As I told you, this is a T-shaped geometry. What this geometry will be? This is in the same plane. The four fluorines are in the same plane. One is above the whiteboard, and lone pair are putting up at the back side of the whiteboard. What kind of geometry should be this? Make sure one thing, that when we mark for the geometry, we only look for the bond pair. Lone pair never ever involves for the geometry. Fine. So that means four of these in the plane and one coming outside. It will be square pyramidal. Lone pair will never be taken up in geometry because lone pair cannot be seen. It's not an atom. It's free electrons, a pair of free electrons. So it never ever takes up for the geometry formation. So it will be a square and a pyramid coming for the outside fluorine. Right? It will be a square pyramidal. Fine. And the next one is IF7. IF7. Iodine is already there. 7 fluorine atoms. 7 fluorine atoms means I can form a kind of a pentagon over here. But it accommodates only 5 in the plane. 1 fluorine towards the whiteboard, from towards your side, and 1 inside. Clear? What kind of this geometry would be? Pentagon bipyramidal. It's a pentagon in plane, 1 pyramid coming towards you guys from the white blackboard, and 1 going at the back. So it will be pentagonal bipyramidal. Two pyramids, bipyramidal. 1 pyramid, only pyramid. Right? Clear? Okay. Now, next slide, please. After interhalogen compounds, this must be very sure to you guys that interhalogen compounds are more reactive than the respective halogen molecules. So if it is IF7, it must be more reactive with fluorine. Though among a group of halogens, we say that the fluorine is the most reactive, least is iodine, and the reactivity goes down the group. Fine? But if you mark any of the interhalogen compounds, they are going to be more reactive than the halogens. Fine? Clear with this? Okay. Now we move to the noble gas element. This completes up with the halogen elements and the family of halogens. Now we come up with the noble gas, that is the group 18 elements. Next slide, please. Noble gas elements comes up with all your helium, neon, argon, krypton, xenon, radon. All of them are the inert gas elements. The inert term was actually coined because they are really inert, because the octet is complete for them. It is sp2 and sp2np6. So octet is complete. There is no vacant orbital line, no extra electron putting up. So they are absolutely satisfied, content kind of, you can say, elements. So they need not to share or to react with anything. So that's why they are inert. They are more stable. So if they don't react, their normal molecular state, or you can say that their state, the original state is monatomic. Fine. However, in case of halogens, the more preferred state is the diatomic, because they form they are incomplete octet, so they form a covalent bond with other halogen and form a diatomic kind of a species. These do not require any kind of electron or do not require to take up or give up an electron. So in that very case, they are happy in their own shell and they don't react with anybody, and they are monoatomic in earth crust. Now all these gases are chemically unreactive. They form very few compounds. Because of this, they are termed as noble gas. Noble was the term given to those who do not want to react with anybody. This term was taken up very later on. First, they were named as inert gas because they don't actually interfere in any kind of reaction. They don't react. They don't actually bother for any kind of a system because their octet is complete. Whole of the periodic table actually performs any of the mechanism or any kind of a reaction to complete its octet. Whatever goes on in the whole of the periodic table is to complete its octet and become stable. They are themselves readily having complete octet. So they need not to do anything. That is why they are inert or called as noble. Right? Now their atmospheric abundance in dry air is merely 1% only, by volume of which argon is the major constituent. You must have seen the major constituent of the gases. The maximum is for nitrogen, then for oxygen, and then argon, and then carbon dioxide and rest of the gases comes up. So argon is the most abundant among the inert gases. Radon is obtained as decay product of rayon. Fine. So it's a radioactive element. Next slide, please. Now, atomic and physical properties says that the electronic configuration, except for helium in a group, only helium has S2, 1s2 kind of a configuration. Rest all the inert gases have ns2, np6. Fine. The p orbital is not there for helium. Rest all have s2, p6 kind of a configuration. Only helium has s1s2 kind of a configuration. See, fine. However, ionization energy means the energy required to form the ion. Ion means whether you take up an electron or give up an electron. Fine. So that is not required by these kinds of inert gases because they are full with octet. So if you need to take up an electron, that is ionization energy, the energy required to take up an electron should be very high, because that is not a probable condition. They really do not want to actually have a vacant orbital. They are absolutely complete. So taking up an electron will be very difficult. That means will require very lot of energy. Lot of energy will be required if you need to take up an electron. So in that very case, the ionization energy is going to be very high for these substances. Fine. So ionization enthalpy is very high due to stable electronic configuration. However, it decreases down the group. As I told you, that the inertness also decreases down the group. It's maximum for the most lying on the top of the group. As we go down the group, the subshell keeps on increasing. Fine. So inertness also decreases in a way that if you say the central mechanism of the nucleus, the central nucleus is kind of a principal or a monitor who's taking care of the rest of the vacant electrons. As the outermost electron goes farther from the nucleus, there you can say the dominance reduces. So the inertness also reduces as we go down the group. So now they are free to move to the external d electrons, d orbitals. They can move away to d orbitals easily. Fine. So as we go down the group, the inertness also decreases to an extent. Though they all are inert molecules, or you can say the inert gases, but the inertness decreases down the group. Fine. Or you can say other way around, the reactivity increases down the group. Fine. Okay. Next slide, please. Now, the atomic radii increases down the group. We all know for all the group, you can say periodic table, the atomic radii increases down the group. However, electron gain enthalpy, due to stable electronic configuration, they have no tendency to accept the electron. As I told you in ionization energy, they do not allow to take up an electron. In electron gain enthalpy, they do not allow to take up an electron also. Neither they want an electron nor they want to give it out an electron. They are absolutely complete. So electron gain enthalpy is also very high for them, right? So is the ionization energy. Neither they want to take up an electron nor they want to give up an electron. That's why they are complete in their own species and they do not react. So they are monatomic. You will never ever get to hear helium 2, xenon 2, argon 2. You are always listening argon, helium, xenon, neon. Because these are the monoatomic gases. They do not react among themselves also. They don't react with anything. Because of which they form a wonderful application in the world because they can be put up in any of the place where the no reaction is required because they won't react at all. So if you want to fill in something where the no reaction kind of a condition is to be performed, you can fill in an inert gas. It won't react with anything. And the volume will also be filled. Right? We'll talk about these in the application part. Next slide. So the physical properties, we say that these are monoatomic. This is very true. Right? Colorless, odorless, because color will get imparted if the electron excitation takes place. Odor will also come up where the electron excitation and tasteless. So their existence does not actually come upon with color, odor, or any kind of, you can say, taste. So sparingly soluble in water because of their inertness. Have very low melting and boiling points because the only type of interatomic interaction in these elements is weak dispersion forces. They don't have any interactions among other molecules. So that means there is no breakage of other bonds required. So phase transformation to melting and boiling point takes up at very low temperature. Very less energy is required and they actually melt very easily or boil very easily. If there are intermolecular attractions or interactions coming upon, only then the boiling and the melting point rises. As in the case of HF I talked about, that there is a hydrogen bonding taking up. So because of which more energy is required to break those bonds between two HF molecules, also the weak hydrogen bonding is to be removed. So to break that molecule, more energy is required, more temperature is to be given. So the boiling point rises. Fine. But here no interaction takes place. So phase transformation can take place at very ease. No extra energy is required. So very low melting and low boiling point actually exist in them. Now, helium has the lowest boiling point, right, of any of the known substance. The boiling point increases down the group because you know that inertness also decreases down the group. So the boiling point will increase down the group. Next slide. Now, chemical properties. Except helium 1s2, all have completely filled octet of S2 P6. Right? Now, they have high ionization enthalpy and positive electron gain enthalpy. Positive electron gain enthalpy means very high gaining enthalpy. The energy is very high to gain an enthalpy, or sorry, an electron. So that means you need lot of energy to make it possible to gain an electron. It's not a very feasible or a spontaneous kind of a reaction. Next slide, please. Okay, so this is a history where it was told that helium, that ionization energy of oxygen was almost identical with that of xenon, because going down the group, you get to see that inertness is decreasing. Fine. So xenon coming at very bottom of the group becomes a little reactive, and the ionization energy is somehow comparable to that of oxygen. Kind of a diagonal behavior you get to see in most of the periodic tables groups. Fine. So what you get to see that a xenon reaction was attempted, and what happened? Xenon was made to react with PtF6 in the presence of some room temperature, and this kind of a molecule was formed. And then it was seen that number of xenon molecules could be reacted, means the xenon was readily available for a lot of reactions under some specific conditions, because though it is reacting, but it's still inert. So some conditions are required, maybe some catalyst, some temperature, some conditions are required. It does not react itself, but some initiation given, it reacts. Right? Next slide. So in that very condition, xenon was reacted with fluorine, and in a mixing of 2:1 or 1:5 or 1:20 at very high temperature, you get to see that it is inert. It does not react under normal conditions. but providing a temperature of 873 or 573 Kelvin, so high temperature, it does react. That means inertness decreases to an extent, but it's still inert. Under normal conditions, it does not react, but providing lot of heat, a lot of energy, it reacts. So it gives you XCF2 in 1:2 ratio, or you can say 1:5 ratio, it gives XCF4 and XCF6, which we have already studied in halogens. Next slide. XCF6 can also be prepared by the interaction of XCF4. What can be done? Like XCF4, if reacted with O2F2, further goes to XCF6, providing oxygen, right? So properties are like XCF2, XCF4, and XCF6 are colorless crystalline solids and sublime readily at room temperature. 298 is the room temperature, right? 298 is 25 degrees Celsius. 298 Kelvin. So they are very powerful fluorinating agents. Fluorinating agents, they are very much fluorinating agents. What are fluorinating agents? Fluorination is required many a times. Your toothpaste contains a lot of fluorinating agents, which strengthens your gums. Calcium and fluorine is very much required for the human body also. Right? Next slide. Now, these are the reactions where XCF2 in presence of water gives xenon back again along with HF and oxygen, because hydrolysis of XCF2 provides you back again Xc. So Xc in xenon in presence of fluorine and some high temperature forms a complex XCF4, XCF2 or XCF6, provided with the temperature and the composition concentration variations, right? But they can be reverted back if these complexes are hydrolyzed, dissolved in water. You get xenon back again. Get to see XCF2 giving you Xc on hydrolysis. So is with the case of XCF4 on hydrolysis gives you Xc, and XCF6 also gives you. But the condition here is it gives you not only xenon but an oxide of xenon. Fine? Because higher is the oxidation state, more difficult it is to get you back the xenon. Right? Next slide, please. Now, XCF2, xenon fluoride reacts with fluoride ion acceptors to form cationic species and fluoride ion donor to form fluoroanions. What happens with these kinds of reactions? A kind of, you can say, cationic anionic complexes are being formed with PF5, SBF5 and MF5. With fluorine acceptors, it gives you different complexes. Fine? Cationic and anionic complexes are being formed. Next slide. Now these are the structures of different xenon fluorides. You get to see that this is XeF2, 2F molecules. Now this time Xe has 8 electron in its outermost shell, or you can say valency is 8, not the outermost shell. Let's say valency is 8. So it should be accommodating 8 electrons outside. One towards fluorine here, one towards fluorine, and fluorine must be having accommodating one more from itself. So that means 2 for xenon for the bond pairs, remaining with 6, forming 3 lone pairs. 1, 2, 3. What geometry it is going to be? Linear. Fine. And the kind of hybridization it is going to be is sp3d. Right? Because p orbital will be requiring 2 of its electrons to move. Okay, when it comes to your square planar, 4 for fluorines, remaining are the 4 electrons forming 2 lone pairs. It will be this way. Now lone pairs do not get added up or associated in the geometry. We never count lone pair for the geometry formation. We only look for the bond pair for the geometry. Fine. So the geometry becomes square planar. Clear? Now the next one is XeF6. Though XeF6 is very easy to be formed, where the 4, you can say, planar structures are in the plane, one down and one above should be there, forming an octahedral geometry. But accommodating 6 fluorine molecules leaves behind 2 electrons, forming one lone pair. So where that lone pair would have accommodated. Fine. So it actually kind of a distorted octahedral is formed. That fluorine gets steric hindrance from this lone pair, and it gets a kind of shift from the 90-degree angle. It gets shifted a bit, and because of which it gets a distorted octahedral structure. Fine. Next slide, please. However, the structure of XeO3 you can get to see, because you know that XeF4 when reacted with water provides a xenon, but XeF6 reacting with water does not provide xenon, it rather it provides XeO3. Fine. So XeO3 is this kind of a structure because oxygen valency is 2. So every time it requires 2 electrons of xenon, each oxygen requires 2 electrons of xenon for the bond pair forming with each oxygen. So it will be 1, 2, 3, 4, 5, 6. Still xenon is left with 1 lone pair, or you can say 2 electrons. So that means this kind of a geometry. Fine. So this is a pyramidal kind of a structure. Clear? Next slide, please. Okay. So XeF6 in water, many a times partial hydrolysis of XeF6 also takes place. Partial hydrolysis means that not in excess of water, little amount of water, the hydrolysis does not lead to XeO3 kind of a formation. It also gives you XeOF4. So always remember in your MCQ, they may ask you that what goes when XeF6 reacts with water. If it is the complete hydrolysis, XeO3 will be formed. But if it is partial, partial means little amount of water is given, displacement of 1 oxygen will take place for 2 fluorine. Because you know, fluorine forms 1 bond with xenon and oxygen forms 2. So you can say take up of 1 oxygen will give up 2 fluorine molecules. So it will form XeF4. Again with little amount of water, because water what it provides oxygen. Again another molecule of oxygen is taking up at the expense of 2 fluorine, so it will be XeO2F2. You need not to mug up, these reactions are very easy. Another partial, this you can say hydrolysis would lead you to these at the expense of these 2 fluorine, you will further get 1 oxygen, so it will be XeFO3. So these are the step-by-step hydrolysis, or you may say the partial hydrolysis of XeF6, which take up at the expense of fluorine. Going, you can say taking up of 1 oxygen will give up 2 fluorine molecules. Just remember that. So step by step, you will get abduction of oxygen. This is a mechanism you can say for the hydrolysis of XeF6, how XeO3 forms. Right? So each fluorine gets off with 1 oxygen. 2 fluorine goes off with 1 oxygen. Fine. So XeOF4 is a colorless volatile liquid and has a square pyramidal molecule, because 4 will be in plane. Fine. 1 will be above oxygen with 2 bonds. There is no need of any of the lone pairs, because 2 bonds, or will there be? Tell me. XeOF4. 4 in plane. 2 oxygen with the molecule, oxygen molecule. How many is left? 2 electrons are left. 1 lone pair, that is at the bottom. But the geometry won't count for the lone pair. So it will be square pyramidal. Fine. So square pyramidal is the geometry. Many a time geometry may be asked in your MCQ. So you must be very clear that what kind of geometry should be formed with the periodic groups. So for that you need to remember the valency. Each element should actually satisfy its valency. Valency does not mean the outermost orbital. Valency means S and P in total, how many electrons constituted. Fine. Like for halogens, it was 7. For inert gases, it's 8. So always make sure that it comes up to be the same. For bond pair, it accommodates only 1 electron. For lone pair, 2 electrons should come up. Fine. Next slide. Now this is the geometry we were talking about. F4, 2 for oxygen, in total 6 bond pairs and 1 left out, remaining lone pair. So the geometry would be square pyramidal, you can see here. The molecular modeling structure is there. Fine. These are fluorines, xenon, oxygen. What happens with the XeF2O? 2. F and oxygen. Oxygen requires 2 each of them. 1, 2, 3, 4. 5 and 6. One lone pair is again left. So the lone pair comes up above. And this is a kind of a seesaw shape. It is not tetrahedral. It is a seesaw shape. Right? Next slide, please. Now, let's talk about the uses of noble gases because they do not have enough of the application in terms of the chemical reactivity because these are inert. So it's only xenon which forms some, you can say, reactions are taken up by xenon, and hence there comes some structures for those reactions we have talked about. Basically, we need to talk about the uses of the halogens, inert elements. So inert element uses comes up with helium because it is non-inflammable and light gas. Light because it is smaller in size also. So it's being used in filling up of the balloons which are used for the meteorological purposes. Right? Along with that, it has very low boiling point. So it is used for cryogenic agent, carrying out various experiments at low temperature. Those experiments which are required at very low temperature, helium gas is used because very low boiling point is there. Right? And what other use is being used there? It is used in NMR spectrophotometers, MRI. You must have heard a lot of time that MRI is required to be done or so and so test is to be done. So for clinical diagnosis, helium gas is being used. And very well known nowadays because you know that when you do the deep sea diving, all those divers are provided with the oxygen cylinders at their back. You cannot provide lot of oxygen inside that because high amount of oxygen won't be easy to be taken up by the divers. So some inert gas is actually added in between so as to make it light also, along with the cylinder should not be very heavy, along with the lesser the pressure inside the cylinder also, because this is an inert gas. It won't react with oxygen molecules. Rather, when it is inhaled by the diver, it does not assimilate in the blood also. Fine, because it is an inert gas. So it really does not actually bother at all to the diver. Rather, it occupies some volume, providing lesser amount of oxygen or providing good space for the oxygen. Fine. So these are the applications for helium. Next slide. Let's talk about the applications for neon, argon, and rest of the inert gases. Now, neon, you must have very well heard nowadays, neon bulbs, because those kind of fluorescent lights are being taken up many a times. The various boutiques and lot of fabric people call about neon colors. Neon colors mean the fluorescent colors. Whatever color, maybe orange, green, blue, red comes up, the fluorescent side or the fluorescent shade of that very color is called as the neon color. Neon, actually the term has been coined because the bulbs where the neon gas is used inside the bulb chamber provides a fluorescent spark, and because of which the light being given by these bulbs is fluorescent. So these are used in the discharge tubes on the fluorescent bulbs, and the bulbs are used for the botanical gardens many a times in botany, or you can say plant lives. And when you look forward for such kind of experiments for plants, we use fluorescent lights, and then neon bulbs are used, right? The application for argon is again kind of very vast, where it is used for the metallurgical purposes, and along with it is used in lab for handling substances there are which are air sensitive. Fine. And xenon and krypton do not have enough of significance because they both have not been taken up enough in the application except for the light bulbs, xenon bulbs and krypton bulbs. That's it. It does not have enough of your applications. Fine. Next, please. And with these applications, we come to an end of the inert gases also. Since they do not react with most of the chemical compounds, or you can say species, they in your course also, the reactions are not there, but the properties, the uses, along with any kind of, you can say, the trends are there, which we have discussed up till now. So any kind of questions are most welcome. कोई क्वेश्चंस है side पे. So this completes your halogen and the noble gas family. I hope this lecture was fruitful for you guys and must have actually helped you to understand both the topics very well. Thank you very much. Yes. Fluorine is used for cleaning because fluorine is very reactive. It does not actually provide any kind of HOF kind of a reaction which should interact with the dye and oxidize it, or you can say the impurity and oxidize it. Does not bring about the oxidation to lesser extent. Being a very strong oxidizing agent, it actually oxidizes to such a great extent that if you want to see, please move back the slides somewhere around 60, 61 slide number. So if you get to see, chlorine and bromine are very good, you can say, water cleaning agents, but fluorine is not, because fluorine reacts very vigorously. It's a very good oxidizing agent. So what happens is that it does not oxidize your dye, because oxidation of dye is required at a little extent, but its very strong oxidizing agent does not actually provide the oxidation of that. It oxidizes itself to HF and O2, I guess. Please make, yes, yeah, yes, that one only. Yes. When you get to see, it actually bring about the oxidation of water. Disproportionation reaction does not occur here. So what happens? It actually readily provides you oxygen. Now, oxygen is a very stable state. It won't oxidize your any of the dyes, impurities, or anything. Fine, it's in the stable state of O2 molecule. Had it been in the HOF form, that does not form, because this being the strongest oxidizing agent, it undergoes reduction rather than disproportionation. Means it goes reduction, but it does not go undergo oxidation. Disproportionation reaction means that the same species undergoes oxidation as well as reduction. But this being very strong oxidizing agent, rest are also oxidizing agent, but they simultaneously undergo reduction and oxidizing agent, hence forming HOCl or HOF, HOBr, fine, which thereafter oxidizes the dye. Here, however, here it does not form so. So it is not a good cleaning agent for water. Its reaction is so vigorous. Neither we want a very vigorous reaction like fluorine, nor we want a very, you can say, insignificant kind of a reaction like iodine, which does not solubilize in water even. Fine. So the best of the options would be chlorine or bromine. Any more questions? Fluorine has more electron gain enthalpy. Enthalpy means energy. Fluorine, since has a smaller size, to gain an electron in the same subshell actually provides the repulsion also. So gaining an electron will be difficult. That means more energy is required than chlorine and bromine. So that means enthalpy will be more, like energy. So it has more electron gain enthalpy. Clear? And it is an oxidizing agent. Oxidizing agent means it itself gets reduced. Fine? Yes. Anything else? Yeah. What was the polarity to do with color? Polarity has nothing to do with color, but it has to do with the solubility. As stated, in the case of halogens are not very polar. So if they are not very polar, the solubility is at a very different variations. And if the solubility as goes is at the different level, so they impart different color. Polarity itself does not come with color. In turn, indirectly it is reacted. If less is the polar, it won't dissolve enough in the non-polar zone. So however in halogens, they are non-polar. So they won't dissolve to great extent in water polar-like bodies. So lesser is the solubility. So color would be different than if the solubility is more in some other organic compound, which is also non-polar. So not directly, but indirectly, color is imparting variations with the polarity. Why is astatine radioactive in nature? Astatine is radioactive in nature because it gives away neutron very easily. Now that reaction comes up because astatine is not very well studied so far because of its very fewer applications. It is radioactive, nothing to do with your halogen family, but it gives away the neutron from its nucleus very readily. That is why it is radioactive. It has nothing to do with the trend of the halogen. The radioactivity comes up with the giving away of the neutron easily. Although fluorine has less negative electron gain enthalpy than chlorine, then why fluorine is more oxidizing agent? I guess this question is incorrect because fluorine has less negative electron gain enthalpy. I have already answered this question. Actually, electron gain enthalpy is high for fluorine. As I told you, I shall just, I guess this question, if prevails for most of the people, then I need to show it up clearly. Electronegativity and electron affinity are very well required to be understood. Like they are required to be understood very clearly. They do not mean the same thing. Electronegativity means that it actually has a tendency to accept an electron. Accept an electron means not in the same subshell, but to share maybe from a covalent bonding and form a bond. That trend is being seen in the oxidizing agent as halogens, because what happens in oxidizing agent, it itself gets reduced. That means it takes up an electron very easily, fine, to form a bond, fine. That means it's a covalent bonding where the electron is not taken up in its own subshell, rather being shared in some other place, and the octet is being also complete. However, electron affinity means taking up an electron and settling up in your own subshell, which goes down for fluorine. Because fluorine already has an very close, or you can say small size. So taking up an electron and adjusting it over here in a small size subshell is very difficult because the neighboring electrons provide a good repulsion to them. So this is the effect of electron affinity, or what you say is electron gaining enthalpy. Fine. However, we form a bond. Bond formation comes up with a covalent bonding also. So in that very case, electronegativity is highest for fluorine. That means when you need to form a bond with some of the element, then electron is not required to be taken up in the same shell. Rather, you share it with some other element. And sharing does not take up in the same subshell. The overlapping happens, and because of which enough of space is also given. Some more space comes up. Some common space is also given. So because of which coming up of an extra electron comes up with an extra space also. So because of which now the reaction is feasible and oxidizing capacity, oxidizing agent is strong enough for fluorine also. Fine. Because with an electron, the bond pair being formed, extra space is also coming up. So there is no problem with the electron-electron repulsions, and hence there is good, you can say, oxidizing power for fluorine. Is that clear? Have I made myself clear? So only with taking up an electron, it's difficult to accommodate an electron for fluorine. However, bonding it up as an oxidizing agent gives you the vacant shell also alongside, or maybe an element with a space and an electron. To understand in a very easy language, a space comes along with the electron, and because of which now the outermost electrons do not have problem, because coming up electron is creating a space also among, so they have no problem. So oxidizing agent or the electronegativity remains the highest for fluorine. Fine. However, only electron coming up is a problem for the outermost shell in case of fluorine. Clear? Okay. Any further question? Okay. Thank you very much, and I hope you enjoyed this topic and understood it to the best of my knowledge and will do well for your JE exams. All the best. हम्म 20 minutes और तो फिर मैं डिस्कस कर लूँ कुछ और ही टॉपिक वापस. Okay, so we can discuss some more questions. Okay, the one I have given you वो नहीं डिस्कस कर सकती मैं इनके साथ. Okay. Okay. So any other topic you want to discuss again? Please read out the question. Question number. Actually, the point number 5 in your lecture notes on page number 1 to 3, I guess it's not given clearly. That's why the doubt prevails. Okay. Let me give you a very deep, or you can say very easy to understand kind of a concept, right? The electron gain enthalpy for fluorine. Halogens have very large electron gain enthalpy. However, as it goes for fluorine, it's not that great. It goes same as that of electron affinity. Now, this is very sure that as the concept says, if you read out your point, you need to switch it on or it's on. Okay. It says that electron gain enthalpy is actually very has less negative electron gain enthalpy for fluorine. Right? Electron gain enthalpy, that means that accommodating an electron for fluorine is not a very easy task. As I told you, electron affinity is also very less. That means accommodating an electron in the same small, you can see here very clearly as I have drawn, then the subshell is very small here. Because of the small size, the subshell already containing 5 electron is small. Right? However, chlorine has a bigger size subshell in which it is containing the 5 electrons. So the new entering electron will experience a greater repulsion from the rest of the electrons in the outermost shell. However, in chlorine that is not the case. Enough of the space is there between the electronic subshells. So that is why electron gain enthalpy has a different trend for fluorine that is in the case of chlorine. However, the oxidizing agent, that means the reaction comprises of F2 going to F plus F plus, because oxidizing agent means accepting an electron. F and F, that means it goes F plus electron giving to F minus, and thereafter F minus, because this is in the gaseous state, acquiring in aqueous state going to F minus in aqueous. This combination of 3 reaction comprises of reduction or acting as oxidizing agent. When we club 3 reactions, then we say the property or the activity of acting as a oxidizing agent comes upon. Here, however, the second reaction is not very feasible, because you know the affinity of electron for fluorine is not that great. However, the third, that is this reaction, is highest for fluorine, because this is a kind of a hydration reaction. Hydration means actually trapping of water molecules. The smaller the molecule, it has more good hydration. Bigger the molecule, difficult to hydrate it. In a very easy language, you can understand the small body is easy to be hydrated than a bigger body. Being small in size, fluorine among the group gets easily hydrated. So this hydration energy is very high, right? And hence this reaction is the most preferred for fluorine. Being oxidizing agent comprises of 3 steps. The second step not very prevalent for the fluorine. However, the third step predominantly prevalent for the fluorine, where its hydration energy gets in favor of fluorine the most. Water accompanying chlorine, bromine and iodine is not that great as that of fluorine because of its small size. So because of which we say that fluorine has maximum hydration energy. So the third step predominantly overpowers the demerits of the second step also. And because of which in totality the act of oxidizing agent is dominated by fluorine, despite the fact the electron affinity is less for fluorine. Getting it? I repeat again, please listen carefully. Electron affinity or accepting an electron, that is electron gain enthalpy, is not great for fluorine because of its small size, small subshell, already accommodating 5 electrons, actually provides a good amount of repulsion from the neighboring electrons. However, in chlorine, you can say the bigger size subshell accommodating same 5 electrons won't require much of a space, or you can say there is much of a difference or distance is quite bigger than in fluorine between the two electrons. So repulsion decreases as we go down the group. So because of which fluorine is having, you can say, lesser electron affinity, or the bond electron gaining enthalpy is different for fluorine. However, the oxidizing agent property comes upon with 3 reactions. Since we all know that halogens exist in diatomic state, so to become an oxidizing agent or to reduce it, we need to first break the diatomic state, which is the first step of oxidizing agent. Thereafter, it takes up an electron, and then the hydration take place. The combination of 3 reactions in totality gives you the oxidizing agent property. Though the second step does not favor fluorine as oxidizing agent among the halogens because of the less electron affinity. However, the third and the final step of oxidizing agent, acting as an oxidizing agent, that is the step of hydration, favors the most for fluorine. Because of the small size, the hydration happens to be the best for the fluorine. It's not lesser for chlorine, thereafter for bromine, and thereafter for iodine. And the variation is such huge that it overpowers the impact of electron affinity as well. So in totality, when we add up, this dominates among both of them, and hence the oxidizing agent, the power goes again back to the fluorine, where it was lost in the case of electron affinity. Getting it? So the hydration energy is very high for fluorine, because of which it empowers or overpowers, or you can say it takes care well of the electron affinity problem of the fluorine. Fine. This is much greater for fluorine, as much it is greater electron affinity for fluorine. So the impact of this, let's say for example, if this is 2x, this will be 10x. So whatever impact is coming up will be taken well care of by this impact. Fine. What say this way. So it will be still in favor of fluorine only. Fine. However, when talking of bond electron gaining enthalpy, we only talk of the second step. So then fluorine does not come along well among the trend of other halogens. Clear? Is it clear now? Any other questions? और कोई questions आए? Any other questions from you guys also? Mm-hmm. Where it is written, page? It's not I2, it's I only. The element which liberated oxygen from water. Since I told you that oxidizing capacity, or it's not about the same group, it's talking about a period. In a period, obviously the halogens can only oxidize to the maximum. Actually, answer should be C. It should be fluorine. It has been marked incorrectly. Since you have seen that iodine, or it's only I is not that soluble in water, answer should be C. It's incorrect. Clathrates. Clathrates are formed when your inert gas elements are actually trapped inside any kind of a cage like a structure. Though they are inert, they do not actually tend to react. And clathrate is that when noble gases get trapped in a cage like a kind of a structure of any of the, you can say, compounds. Though they do not react, they do not interfere in the structure, they just get trapped. And the best clathrate will be formed, the smaller will be the structure. It's better to actually accommodate any small species inside any of the hole than a bigger one. So if we say which will form the best of the clathrate, helium, neon, argon, krypton, xenon, the answer would be helium. Fine. The smaller the size, better the clathrate. Fine. Any other question? I guess thank you very much and all the best for your JE exam.
So good afternoon, everyone. So we'll be discussing the problems which you have shared with us. So one of the problem which you have shared with us is the melting point and solubility comparison of para-dichlorobenzene and meta-dichlorobenzene and ortho-dichlorobenzene. So herein we have to compare the solubility of these three isomers of para-dichlorobenzene, dichlorobenzenes, and melting point comparison. So any guess which one is having the best or the highest melting point out of three? The first one, why? Very true. So para-dichlorobenzene has the highest melting point amongst the other two, because melting point does not only depend upon intermolecular force of attraction. Along with intermolecular force of attraction, also depends upon how well they pack. Because in melting point, you're just breaking the solid lattice and fusing it into liquid. So in that case, the lattice packing would be better if the molecule is symmetric. Second more important factor, which you can also include, though that is not very significant in comparison to the first factor, that is because of the linear shape, the surface area of the molecule is larger, right? And because of the other kind of shape, not really linear, so the surface area of the molecule is relatively less, and thereby this molecule would have stronger intermolecular force of attraction in comparison to the other. Now, this is one case. Second was the solubility of dichlorobenzene isomers. So again, who will have the best solubility? So that will depend upon, so in which kind of liquid I'm observing their solubility. Okay, if I am observing the solubility in non-polar solvents, which should be the case because this is completely non-polar in nature, would barely dissolve in a polar solvent. So if I consider its solubility in non-polar solvent, it will be very high. And in case of a non-polar solvent, the solubility of the meta and ortho isomer would be very less, because these two are polar in nature. Why they're polar in nature? And this one is non-polar. So dipole moment of para-dichlorobenzene would be 0. So which you can see in this case. Here this bond would be polar and this bond would be polar. In this case, this bond would be polar and this bond would be polar. Since dipole moment is a vector quantity, this total sum would be 0. In this case, it will not be a 0 value. Same goes for this case. So these two molecules would be polar and this one would be non-polar and would show highest solubility in non-polar solvent and lowest solubility in polar solvent. Right. So this is the first problem which we had. Hinsberg test. The second problem is on the Hinsberg test, which is used to distinguish primary, secondary, and tertiary amine. So the question is simple. I would just read out the question. The question says that Hinsberg test is used to distinguish between 1 degree, 2 degree, and 3 degree amines. In this test, when 2 degree amine reacts with Hinsberg's reagent, it forms A. Determine compound A. So for that, like we just understand the what is Hinsberg test. So in Hinsberg test, we make the amine react with a reagent called para-toluene sulfonyl chloride. So for example, I have a primary amine RNS2. Here nitrogen has a lone pair of electron. This sulfur is electrophilic in nature and can accept the attack of nucleophile. So this nitrogen will attack on the sulfur with its lone pair, pi bond will get shift, and this would result in nucleophilic acyl substitution. and HCl will come out. So I've not shown the entire mechanism. So in this case, so nothing would happen. So this pi bond will break down, O minus will form. This oxygen will again push the electrons, and Cl would come out as a leaving group. So this is called nucleophilic acyl substitution, SNAC. In this case, HCl will come out not as a whole molecule, but in the form of H plus separately and Cl minus separately. So HCl will be there in the solution. So this is the product of the reaction. These are sulfonamides. So if I have secondary amine, let's suppose this is the secondary amine I've got, and I make it react with para-toluene sulfonyl chloride, then again through the same mechanism of reaction, it will be producing NN dialkyl sulfonamide, S double bond O, N, R. So 2 R groups will attach here. So this is the compound which you will get as A in the question. Right? Marker na jayega. इसका क्या दे दीजिए. There is a question on solubility product. The question is, so we have a salt, magnesium hydroxide, whose Ksp or solubility product is given to us. This is 1 into 10 to the power minus 11. It says that at what pH magnesium ions will start precipitating in the form of magnesium hydroxide to form a solution, in the form of a magnesium hydroxide from a solution of 0.001 molar magnesium ions. So what exactly is happening in this solution is, so we have a solution of magnesium ion. It contains 0.001 molar magnesium ions, right? So what we're doing it, so we just trying to precipitate the solution, and we're just looking for at what pH this solution will precipitate, right? For the precipitation, we know that ionic product has to be more than the solubility product, right? At this condition, the solution becomes supersaturated and precipitation will start. Now, this question has given us solubility product, temperature 25 degrees Celsius is given, and it has asked for the pH value at which this will happen. This precipitation will happen. So let's first identify what is the concentration of OH minus which is required so that the precipitation will happen, right? So this magnesium hydroxide, when it will dissolve in water, it will ionize and will give you magnesium ions and hydroxyl ions, right? If S molar, S is the solubility, for example, would dissolve in water, then the concentration of magnesium ion will be S, and this will be 2S, and this small s is called solubility of the salt. But right now, let's not focus on solubility. So we can say that what the Ksp will be equal to magnesium ion concentration and hydroxyl ion concentration का whole square. In fact, अगर आप if you just compare, ये जो पहले आपने पढ़ा होगा Kc is equal to Qc वाला concept, this is nothing but the same thing. This is nothing but Qc, and this is nothing but Kc which you're doing here. So if your Qc becomes greater than Kc, the reaction moves in the backward direction, which means precipitation will dominate. So herein, in this condition, let's assume at this concentration of magnesium ion, solution is saturated. So इस condition पे अगर मैं concentration of OH minus निकालूं कि जिस OH minus का कितना limiting concentration है जिस पे solution अभी भी saturated रहेगा, ठीक है? अगर उससे ज्यादा OH minus हो गया तो precipitate कर जाएगा, उससे कम रहा तो unsaturated रहेगा और salt dissolve कर सकता है. तो मैंने by default मान लिया कि solution अभी saturated है और उस समय पर इसकी concentration है 0.001. इसकी कॉन्सेंट्रेशन मुझे पता नहीं है, ये मुझे कैलकुलेट करनी है, और KSP का जो वैल्यू है ये गिवन है मुझे 10⁻11. सो कॉन्सेंट्रेशन ऑफ OH माइनस आ जाएगा, दिस विल बी हाउ मच, 1/1000 here 10⁻8 का स्क्वायर 10⁻4 मोलर. So this is the concentration of OH minus at which just solution is saturated. अगर मैं थोड़ा सा भी इसको ज्यादा करता हूं, this part which is QC or ionic product will be more than the value of solubility product, and the moment it becomes larger than this, the precipitation will start. So which means I can say that for any concentration of OH minus greater than 10⁻4 molar, the precipitation will start. Right? So for concentration of OH minus to be 10⁻4, what is the value of POH? Minus log of 10⁻4. So it will be 4. So pH will be equal to 14 minus 4, which means 10. Right? So the condition of pH would be not 10, but less than 10 or more than 10. For any value of concentration of OH greater than 10⁻4, which means this power will go down. Let's suppose 10⁻3. So OH would be 3 and pH would be 11. So for any value of pH greater than 10, the precipitation will happen. Right? Okay, why I could take 14, or I can just ask why 25 degrees Celsius is given in the question. What is the significance of giving 25 degrees Celsius? अगर ये नहीं दिया होता तो क्या प्रॉब्लम होती, या कोई और टेम्परेचर दिया होता तो क्या प्रॉब्लम होती? So I've used a formula here directly. Okay, the formula is that pH plus POH is equal to pKW, right? And as we know, the value of Kw is 1 into 10⁻14 at 25 degrees Celsius. If you change the temperature, the value of Kw changes, thereby value of pKw will change, and thereby value of pH or POH in this question will change. In fact, if I change the temperature, the value of pH scale itself will change. You must have like, for example, I just give you a question around this concept. You can just see, for example, if I have a value of Kw to be equal to 10⁻13 at, for example, T some temperature Kelvin, right? Then what is the nature of a solution having pH is equal to 6.7? Is it acidic, basic, or neutral? Basic? Why? हाँ, neutral हो जाएगा, exactly. So if you change the value of Kw, that which changes with temperature, because the ionization of H2O is an endothermic process. It will break down to H3O plus and OH minus, where so Kw is equal to concentration of H3O plus into concentration of OH minus. Since the concentration of 2 would be same because both of them are coming from H2O, or 1:1 is the molar ratio in the product, so in दोनों का concentration would be same. So if this value is 10⁻14, so I can say that concentration of H3O plus whole square would be 10⁻7. But if this value goes to 10⁻13, then concentration of H3O plus in neutral medium will be 10⁻6.5 molar. So at pH 6.5, the solution would be neutral, and at pH 6.7, the solution will be basic. So the pH scale itself can shift on temperature. So there are certain questions around the rate of diffusion of a gas. So let me just pick up a question around that concept. So the question is pretty simple. So there is a long narrow tube, which is its length is 1 meter, and the two ends of the tube are connected to two cylinders. One is filled completely with ammonia, another is filled completely with HCl gas. Now both the cylinders are at identical conditions, which means contain same amount of gases, same pressure of the gases. Now the tube is right now at vacuum. दोनों एंड से हमने एक स्टॉप वॉल्व लगाया हुआ है, दोनों वॉल स्टॉप वॉल को एक साथ ओपन कर दिया, तो यहां से अमोनिया गैस वुड मूव इन, यहां से HCl गैस वुड मूव इन. तो द पॉइंट वेयर दे वुड मीट फर्स्ट, तो वहां पर क्या होगा, अमोनिया गैस और HCl गैस इनकी आपस में रिएक्शन होगी एंड दे विल फॉर्म अमोनियम क्लोराइड. सो अमोनियम क्लोराइड के सॉलिड बहुत छोटे छोटे पार्टिकल्स बनेंगे विच आर व्हाइट इन कलर, एंड एक्चुअली जिस पॉइंट पे ये स्ट्राइक करेंगे वहां पर यू वुड ऑब्जर्व अ व्हाइट क्लाउड or white fumes we can say. So question is, what is the value of X where you would see the white spark first? You can take a minute and try and solve this question and we'll discuss that. Let's discuss this problem. So this question is completely based on rate of diffusion or rate of effusion, I would say. So when we say that there is a narrow tube, then rate of diffusion can be completely correlated with speed of the gas molecules or the average speed of overall the gas molecules. So herein, this problem is something like a problem which you must have done in physics on the relative velocity, that there is a bridge, one train is coming from this side, one train is coming from this side. कौन सा पॉइंट होगा जब ट्रेन्स दोनों एक दूसरे को पहली बार क्रॉस मतलब पॉइंट मिलेंगी या क्रॉस करेंगी, तो उस केस में व्हाट वी डू, सो ईदर वी सॉल्व इट थ्रू रिलेटिव वेलोसिटी और वी से दैट कि अमोनिया को यहां से यहां पहुंचने में जो टाइम लगा होगा एग्जैक्टली उतना ही टाइम HCl को यहां से यहां पहुंचने में लगा होगा, राइट. इफ आई से दैट रेट ऑफ डिफ्यूजन is distance traveled by gas in a narrow tube is equal to time taken, sorry, upon time taken. So then rate of diffusion of ammonia would be equal to distance traveled by ammonia, which is x meters, upon time taken by ammonia. Similarly, rate of diffusion of HCl would be equal to the 1 minus x meter. This distance would be 1 minus x meters and time taken by HCl. Now I can say that if both of them started from the same time, both will reach this point in same time. Though the one which is moving faster would cover more distance, the one which is moving slower would cover less distance. I don't know whether ammonia is moving faster or HCl is moving faster. So let's figure that out. Who is moving faster? So I can say that time taken by ammonia to reach that first point of meeting is equal to time taken by HCl. So it will become equal to x upon rate of diffusion of ammonia 1 minus x upon rate of diffusion of HCl. So x upon 1 minus x is equal to rate of diffusion of ammonia upon rate of diffusion of HCl. Now as we know that rate of diffusion is proportional to partial pressure gradient of a gas and inversely proportional to square root of molar mass of gas, right? So in like simple terms, I would say it's P by root M. Since both the gas are under identical conditions, the pressure would be same, but molar masses would be different. So I can just convert this thing into, so x upon 1 minus x is equal to rate of diffusion of ammonia upon rate of diffusion of HCl. This will become ratio of molar mass of HCl upon molar mass of ammonia, right? अब ये masses हमें पता ही है, so we can calculate x. So HCl का mass is 36.5, ammonia is 17. Using this equation, you can solve the value of x. अच्छा, just by without solving this question itself, could you tell me that this x would be like more than 50% or less than 50%, or simply the ammonia would move faster or HCl would move faster because it's a lighter gas? This one कैसे? अगर मैं v1 स्क्वायर अपॉन v2 स्क्वायर लेता, काइनेटिक एनर्जी दोनों का सेम टेम्परेचर, दोनों की काइनेटिक एनर्जी सेम है, ठीक है, बट उससे आपको x कैसे मिलता? हाँ, अच्छा, तो आप कह रहे हो कि ये आपको इसका आइडिया लग जाता, ओके, हाँ ठीक है. So this is the graph which is called Maxwell-Boltzmann distribution of speeds. So I hope you understand this graph. So this is a pretty simple graph which you have studied in statistics. ठीक है, तो it's a frequency distribution graph. तो on the x-axis मैंने speed of molecules plot किया. For example, जो भी molecules move कर रहे हैं उनकी speed एक value से लेके maximum इस value तक let's suppose जा सकती है. y-axis पे मैंने plot किया fraction of molecules. तो it's as simple as that कि भाई मैंने कहा कि यार this is the speed with which some molecules are moving. How many molecules are having the same speed? वो मैं यहां से निकाल लूंगा, right? So For example, I said कि let's suppose the speed is for example 10 to the power 3 meter per second. So how many molecules in the entire gaseous sample having same value of speed? सबकी exactly यही value of speed आ रही है. So that fraction or percentage is plotted on the y-axis. तो वो सारी values इस तरह से आप लोग समझ सकते हो. ठीक है. अब मैंने क्या किया, मैंने 3 डिस्ट्रीब्यूशन ग्राफ बनाए हैं ABC. अब इसके ऊपर 2 क्वेश्चन है. क्वेश्चन 1 कि अगर मैं कहता हूं कि A, B and C are graphs of a same gas. तीनों ग्राफ सेम गैस के लिए बनाए गए हैं, बट टेम्परेचर्स डिफरेंट हैं. प्लॉटेड एट टू 3 डिफरेंट टेम्परेचर्स TA, TB एंड TC. ठीक है भाई. जैसे फॉर एग्जांपल ये सपोज मैंने हाइड्रोजन गैस के ग्राफ प्लॉट किया, ये भी हाइड्रोजन गैस के लिए, ये भी हाइड्रोजन गैस के लिए, तो मैं यहां पे लिख देता हूं. सो फॉर एग्जांपल दिस all the 3 graphs are plotted for hydrogen gas, but this gas which is hydrogen gas in container जो इसमें ग्राफ प्लॉट किया है, इसका टेम्परेचर अलग है, इस वाले का टेम्परेचर अलग है और इस वाले का टेम्परेचर अलग है. ठीक है. तो आपको ये बताना है कि इन तीनों का आपस में क्या रिलेशन होगा. Will this be the case or this be the case or some other case which you feel like for example कि मैं गलत बोल रहा हूं कि अलग अलग होगा, ये तीनों सेम ही होंगे, या फिर मे बी सम रैंडम केस लाइक दिस काइंड ऑफ. So for example, these are 4 options A, B, C and D. So one or more than one correct. Why? Molecules will be no. Okay, let's understand one thing. There is something, this is again related to the graph. That concept is again related to the graph. The concept is, if I take the area under the curve, मैथ्स में पढ़ा ही होगा हमने एरिया अंडर द कर्व. ठीक है ना. तो अगर मैं, या फिजिक्स में भी आपने काफी जगह यूज किया होगा वर्क पर एनर्जी में पीवी डायग्राम के थ्रू वर्क निकालने का. ठीक है. तो अगर मैं इस कर्व के अंडर एरिया निकालता हूं, टोटल एरिया किसी भी कर्व के अंडर, तो इट विल गिव मी टोटल नंबर ऑफ मॉलिक्यूल्स. अगर मैं एक लिमिट डिफाइन करता हूं, फॉर एग्जांपल मैंने कहा कि कितने मॉलिक्यूल्स हैं जो कर्व ए के मतलब वाले सिचुएशन में जिनकी स्पीड 10 की पावर 3 मीटर पर सेकंड से कम है. तो फॉर एग्जांपल मैंने कहा ये लोवेस्ट पॉसिबल स्पीड है, ये हाईएस्ट, ये वाली मेरी लिमिट है. तो जो मैं अगर लिमिट डिफाइन कर देता हूं, फॉर एग्जांपल स्पीड v1 टू v2, इस वाले पोर्शन ऑफ कर्व के अंदर जो एरिया आएगा, दिस विल गिव मी नंबर ऑफ मॉलिक्यूल्स जिनकी स्पीड इस रेंज से इस रेंज के बीच में लाई करती है. ठीक है. अब लेट्स सपोज मैं कहता हूं कि यार ऑब्वियसली स्पीड ऐसे प्लॉट करा है मैंने, तो ये लोअर स्पीड्स है, ये कुछ मॉडरेट एवरेज स्पीड्स होंगी, कुछ इसके आसपास वैल्यूज होंगी, एंड दीस विल बी दी हाई स्पीड्स. ठीक है. तो फॉर एग्जांपल मैंने कहा कि यार लेट्स सपोज ये कुछ वैल्यू है, इसके बियॉन्ड any speed will be, I would say that it's a high speed of molecule. ठीक है. तो for curve A, the molecules having higher speed is less, है ना. भी मैंने कहा इसके बियॉन्ड जो भी स्पीड होगी वो हाई स्पीड, मतलब वो वाले मॉलिक्यूल्स की बात हो रही है जो हाई स्पीड पे मूव कर रहे हैं. और उस पोर्शन के अंडर का जो एरिया, मतलब कर्व है हमारा, उसके अंडर जो एरिया मैं कैलकुलेट करूंगा, दैट एरिया विल गिव मी नंबर ऑफ मॉलिक्यूल्स हैविंग speeds higher than this value. So let's suppose all the speeds above this speed value is high speed. ठीक है. तो अब जो A सिचुएशन है, यानी A वाला जो ग्राफ मैंने बनाया है हाइड्रोजन गैस के लिए ही, इस टेम्परेचर पे, इसमें कितने मॉलिक्यूल्स हैं हाई स्पीड पे जो मूव कर रहे हैं, ये वाले ग्राफ के हिसाब से. ठीक है. अब यही चीज B और C में देखते हैं. B वाले में कितने होंगे इसके कर्व के हिसाब से. B का कर्व कहां से चालू हो रहा है, यहां से यहां पे, तो इसके अंडर का एरिया काफी ज्यादा है. So number of molecules of B having high speeds is larger. ठीक है. Same thing is happening in C. तो C वाले में अगर मैं निकालूंगा तो C का कौन सा ये पोर्शन है कर्व का, ये वाला, इसके अंडर का एरिया और भी ज्यादा आएगा. तो एक चीज मुझे समझ में ये आ रही है कि A, B, C 3 सिचुएशंस में C वाला ऐसा सिचुएशन है जिसमें बहुत सारे मॉलिक्यूल्स हैं जिनकी स्पीड बहुत ज्यादा है. B वालों की स्पीड्स B में ऐसे मॉलिक्यूल जिनकी स्पीड बहुत ज्यादा हो कम है. A में ऐसे मॉलिक्यूल जिनकी स्पीड बहुत ज्यादा हो और भी कम है. नाउ अब हमने ये पढ़ा है कि जो मॉलिक्यूल्स की स्पीड होती है वो टेम्परेचर पे डिपेंड करती है। तो ज्यादा टेम्परेचर होगा तो ज्यादा मॉलिक्यूल ज्यादा स्पीड लेके बैठे होंगे, राइट और नो? ठीक है, तो किस केस में ऐसे ज्यादा मॉलिक्यूल हैं जिनकी स्पीड ज्यादा है? सी में। तो विच मींस टेम्परेचर of this condition would be higher than temperature of this condition and will be higher than this temperature of this condition, which means this one is correct. ठीक है, ये अगर आप बहुत प्रैक्टिकली देखो तो बहुत सिंपल सा एग्जांपल है। लेट्स सपोज, मतलब ये बहुत कहीं पे भी आप प्रैक्टिकली अप्लाई कर सकते हो। फॉर एग्जांपल मैंने बहुत सारे बच्चों का टेस्ट लिया, ठीक है, और मैंने यहाँ पे मार्क्स प्लॉट कर दिए। अब फॉर एग्जांपल 100 मार्क्स का टेस्ट है, वैल्यूज आ सकती हैं 0 1 2 3 4 100, तो मैंने सारी वैल्यूज यहाँ प्लॉट कर दी। लेकिन बहुत फॉर एग्जांपल 1 लाख स्टूडेंट्स वो टेस्ट दे रहे हैं, तो ऑल दी 1 लाख स्टूडेंट्स जो टेस्ट दे रहे हैं सबके यूनिक मार्क्स तो नहीं आएंगे। 43 मार्क्स बहुत सारे बच्चों के आए होंगे, 3 मार्क्स बहुत सारे बच्चों के आए होंगे, 0 भी बहुत सारे के आए होंगे। तो मैं प्लॉट करता चला गया, तो 0 मार्क्स कितने बच्चों के आए, 1 मार्क कितने बच्चों के आए, 2 कितने के आए, एंड सो ऑन। तो ऐसे ही ग्राफ्स बन जाएंगे। ठीक है, अब मैंने 3 केसेस बनाए, तो मैंने कहा मैं 3 बार पेपर कराऊंगा। एक बार पेपर में रखूंगा बहुत डिफिकल्ट, दूसरी बार में रखूंगा इजी, और तीसरी बार एक सुपर इजी पेपर रख दूंगा। तो व्हेन आई टेक सुपर इजी पेपर, देन इन दैट सुपर इजी पेपर बहुत सारे बच्चों के ज्यादा ज्यादा मार्क्स आएंगे। तो फॉर एग्जांपल दिस ज्यादा मार्क्स। तो just consider the temperature at the easiness here, which is actually increasing the number of those kids जो फॉर एग्जाम्पल 60% के अबव है, लेट्स सपोज। ठीक है, तो ये एक इंप्लीकेशन है इसका। तो अब इसका, तो अब यहाँ पे अगर मैं कमिंग बैक टू द केमिस्ट्री थिंग, मतलब कमिंग आउट ऑफ द एनालॉजी, तो हम ये कह सकते हैं कि अगर मैं एक ही गैस के लिए टेम्परेचर इंक्रीज करता हूं तो नंबर ऑफ मॉलिक्यूल्स अटेनिंग हाई स्पीड्स विल इंक्रीज, और यू कैन से दैट ये जो ग्राफ है ये फ्लैटन होता चला जाएगा। इसलिए कि मैंने इस ग्राफ को पकड़ के दबा दिया और फ्लैटन, और टेम्परेचर बढ़ाऊंगा तो फर्दर सपोज मैंने इससे भी हाई टेम्परेचर ले लिया, तो जो ग्राफ प्लॉट होगा वो और भी फ्लैट हो जाएगा पहले से। तो पीक की हाईएस्ट हाईएस्ट वैल्यू छोटी होती जाएगी लेकिन डिस्ट्रीब्यूशन बड़ा होता चला जाएगा, विच मींस हाई की तरफ ज्यादा मॉलिक्यूल्स वाले केस हो जाएंगे। ठीक है, इसी में ही एक दूसरा क्वेश्चन बनता है विच इज, ये नोट कर लिया आपने? ठीक है, इसी में ही सेकंड एक क्वेश्चन ये बनता है कि ये तीनों डिफरेंट, अब ये टेम्परेचर तीनों सेम है ना, ऑल द थ्री टेम्परेचर्स आर सेम। दिस इज द टेम्परेचर T, this is the temperature T, this is the temperature T. So now what I'm doing is I'm changing the gas. So I'm saying that, so what I've done is I've taken 3 gases, methane, hydrogen gas and carbon dioxide gas, right? So which graph would belong to which gas? तो CO2 का ग्राफ ए होगा कि CH4 का ग्राफ ए होगा कि हाइड्रोजन का ग्राफ ए होगा? तो ये तीनों ग्राफ सेम टेम्परेचर पे बनाए गए हैं और अलग अलग गैसेस के लिए बनाए गए हैं। तो आपको आइडेंटिफाई करना है कि ये गैस का कौन सा वाला ग्राफ है, ये वाले गैस का कौन सा ग्राफ है, और ये वाले गैस का कौन सा वाला ग्राफ है। CO2 का ए होगा और वाई। ज्यादा होगी, परफेक्ट, ये तो पकड़ लिया आपने सही से। सो काइनेटिक एनर्जी is half mv square, right? And kinetic energy depends upon temperature. So if temperature of all the three gases is same, so their average kinetic energy will be same. Now if mass of the molecule is higher, then thereby speed of the molecules will be lower, right? तो अब इन तीनों में से हेवीएस्ट है ये, इसका मॉलिक्यूलर वेट 44 है, इसका 16 है और इसका 2 हो गया। सो दिस इज द हेवीएस्ट मॉलिक्यूल, तो इसके सारे मॉलिक्यूल्स की वेलोसिटी वुड बी लेस इन कंपैरिजन टू ओवरऑल velocities of methane gas molecules gases and hydrogen molecules. तो यानी कि ग्राफ A would belong to CO2, B would belong to CH4 and C would belong to H2. So इसमें सिंपल सा रूल आप ध्यान रख सकते हो, अगर तीनों ग्राफ में टेम्परेचर सेम है और 3 ग्राफ्स अलग अलग गैसेस के लिए हैं, तो लाइटर गैसेस का ग्राफ फ्लैटेंड होगा। बता दूं? So let's do a question on chemical kinetics. ठीक है? So एक reaction है A2 products. This is a first order reaction. ठीक है? तो initial concentration of A, which means concentration of A at time t0. This concentration is, for example, 1 molar. Concentration of A at time t is equal to 6 minutes. This is 0.8 molar. Right? So now we have just measured these two concentrations at these two time points. Now I let the reaction happen. So what I'm saying that you need to calculate the time required for 20% decrease in concentration of A, which is left at t is equal to 10 minutes. So if you have understood the question, or I can just like give you like explanation around it. So ये अपना एक सिंगल एक रिएक्टेंट है A. इनिशियली टाइम t0 पे इसकी कंसंट्रेशन 1 मोलर है, टाइम t इक्वल टू 6 मिनट्स पे इसकी कंसंट्रेशन 0.8 मोलर है. नाउ व्हाट आई एम सेइंग दैट टाइम t इज इक्वल टू 10 मिनट्स पे A जितना बचा होगा, सो द A लेफ्ट एट t इक्वल टू 10 मिनट्स, उसका 20% डिक्रीज होने में कितना टाइम लगेगा? दैट टाइम यू हैव टू फिगर आउट. So you can take a minute or two and just solve this question, and then I'll discuss. Four minutes, no. 4 minutes not a right answer. So let's discuss this problem. So I think, so possibly what we have been doing is, we're just trying to apply this formula here, which is valid for first order reactions. So K is the rate constant of the reaction, right, upon time t, log of A naught upon AT. So now, these two values are given to us. So we can probably solve K 2.303 by T. This is 6 minutes, which is given to us, log of A naught upon A6. So this is 1 molar, this is 0.8 molar. And I would solve it, and eventually I'll get the value of K. Okay, so let's not solve it. Let's just move on to the next step. So next step says that I want to calculate the time which is required for 20% decrease in concentration of A left at t is equal to 10 minutes. So if 20% of this concentration will decrease, then how much concentration of A will be left? 80% of this value. So I need to calculate the time t which takes us to take this value to its 80%. So this t is equal to 10 को मैं लिख रहा हूँ A10, which means concentration of A at 10 minutes. And this is the time which we have to calculate. Applying the same formula here, so t is equal to 2.303 upon k log of A10 upon 0.8 of 8. Right? So some student must have attempted to calculate the concentration of A at t is equal to 10 minutes. But if you look at this formula, this value is not required to be calculated. It will cancel out. Okay? So if I see that k is equal to 2.303 upon k log of 1 upon 0.8, and I just substitute the value of k here, the time will come out to be 6 minutes. Right? So this is the approach with which we can solve this question. The second thing which we can also do in solving this question is we can use a concept, and without actually putting down any formula, we can say that its answer is 6 minutes. How can we say that? In first order reaction, the percentage change anywhere in the reaction happens in same amount of time, which means, let's suppose I have some concentration of A as the reactant product. Let's suppose its concentration at some time t is 80, right? And I say that x% of A reacted. So if x% of A will react, then how much of amount of A will be left behind? 100 minus x upon 100. Right? Now, if I calculate the time which it took for this x% change, this will be 2.303 upon k log of 80 upon 100 minus x upon 100 into 80. So this will cancel out. Now, so t is equal to 2.303 upon k log of 100 upon 100 minus x. If you see in this example, the k is a constant value which will not change throughout the reaction. It's a specific constant, right? So this time t depends upon what? Only variable, that is x, and that x is the percentage change which has happened to A. राइट? अब यहाँ पे जो मैंने A लिया था ये कैंसिल हो गया, तो इससे तो कोई फर्क ही नहीं पड़ता कि मैं किस कॉन्सेंट्रेशन की बात कर रहा हूं. तो अगर मैं 20% कॉन्सेंट्रेशन मेरी 6 मिनट में डिक्रीज होती है, तो 20% कॉन्सेंट्रेशन रिएक्शन में कहीं पर भी 6 मिनट में ही चेंज होगी. इसका परफेक्ट एग्जांपल है हाफ लाइफ, जो आपने पढ़ा है लेकिन हम उसको अप्लाई नहीं कर पा रहे. सो हाफ लाइफ फर्स्ट ऑर्डर रिएक्शन में कांस्टेंट रहती है. इट डज नॉट चेंज विद कॉन्सेंट्रेशन ऑफ ए. इसका मतलब क्या हुआ? हाफ लाइफ क्या होता है? 50% टाइम रिक्वायर्ड फॉर द 50% decrease in concentration of A. Now, if 50% change happens in same time at anywhere in the reaction, it means any percentage change will happen in the same time period. That is what we are showing here. So if I know this concept, I do not have to do any calculation here. This question could have been made more complicated and eventually would land up to the same answer. But you can just directly say that because it's a first order reaction, same percentage change will happen in same time period. यहाँ पे 1 मोलर से जा रहा था 0.8 मोलर, which means A का 20% डिक्रीज हो रहा था 6 मिनट्स में, और यहां पर मैं कितना निकाल रहा हूं? 20% डिक्रीज, तो इट विल आल्सो हैपन इन 6 मिनट्स. दैट्स द लॉजिक वी कैन अप्लाई हियर. You can get noted down and we'll solve another problem. Okay, so let's move on to the next question. I hope you have written it. So next question is around liquid solutions. So it says that 0.04 molar solution of sodium sulfate is isotonic with 0.01 molar solution of glucose at the same temperature. Find out the apparent degree of dissociation of sodium sulfate. So there are two solutions. One is sodium sulfate aqueous solution, another is glucose aqueous solution. ठीक है, both the solutions are isotonic. Isotonic का क्या मतलब है? Same osmotic pressure. So when a solution is when two solutions are isotonic, it means both of them are having same osmotic pressure value. So osmotic pressure of sodium sulfate is equal to osmotic pressure of glucose. Now the value of the formula for osmotic pressure is ICRT. I'm including I as a Ventov factor. If the solute would not associate or dissociate, the I will automatically become 1 and the formula will become CRT automatically. If it's associating or dissociating, the I would actually correct the formula accordingly. So it would be better if you always use this formula instead of CRT. So in glucose, I would be 1 as we can see, but in sodium sulfate, I will not be 1, right? So I would just apply the formula. So I of sodium sulfate, CRT, concentration of sodium sulfate is given to us. This is 0.004 molar. Both of them are at same temperature, 25 degrees Celsius. RT, so don't have to write. So this will cancel out. I of glucose would be 1. I just write it 0.01 and then RT. So this will cancel out. This is 1. So sodium sulfate Ventov factor will be 0.01 into 1 upon 0.004. तो कितना वैल्यू आ जाएगा ये? 10 by 4, 2.5. Right? If sodium sulfate would have dissociated completely, तो इसका Ventov factor कितना आता? 3. लेकिन ये 3 नहीं आ रहा है. इसका मतलब ये 100% आयनाइजेशन नहीं हुआ है. और एक्चुअली उसने पूछा क्या हमसे? यही पूछा है कि कितना डिग्री ऑफ आयनाइजेशन हो रहा है. तो अगर हमें Ventov factor पता चल चुका है इसका, तो डिग्री ऑफ आयनाइजेशन निकाल सकते हैं. कैसे निकाल सकते हैं हम लोग? हम एक ट्रीटमेंट करते हैं डिग्री ऑफ आयनाइजेशन और Ventov factor का, जिसके थ्रू फॉर्मूला आपका एक जनरेट होता है इक्वल टू 1 alpha is equal to I minus 1 and upon n minus 1, where n is the number of particles or ions this solute would be generating as per molecule. तो एक मॉलिक्यूल से कितने पार्टिकल्स आएंगे? 3 आएंगे, 2 सोडियम आयंस and 1 सल्फेट आयन. So n would be definitely 3. I is given to us 2.5 minus 1. So alpha would be 1.5 upon 2, which means 0.75. So this is the degree of ionization, which means fraction of ionization. So percentage would be 75% ionization. there is another question belonging to the same chapter, which is there in the doubts. The question is a part on relative lowering of vapor pressure and purely based on Oswald-Walker experiment. The question is, the dry air is successfully passed through a solution of 5-gram solute in 80-gram water. So we have a solution in which there is some solute, I don't know what solute is, and we have made a solution of it, and we are passing dry air through the solution. Right? And then it's passed through pure water. So on doing that, the loss in weight of solution was 2.5 gram. So there is a decrease in total weight of the solution, that is 2.5 gram. And that of pure water container, it is 0.04 gram. So you have to find the molecular weight of the solute. How would we solve this question? Question समझ में आ गया? नहीं. Okay. So I'll just give you a brief of the Oswald-Walker experiment. So relative lowering of vapor pressure हमने सबने पढ़ा ही है, qualitative property होता है P naught minus PS upon P naught, right? तो experimentally उसको कैसे measure करते हैं? That experiment is a very popular experiment called Oswald-Walker experiment. तो उसका फॉर्मूला, मतलब उसका जो डायग्राम है काफी टीडियस है, बट मैं उसका थोड़ा स्कीमेटिक सिंपल डायग्राम यूज कर रहा हूं समझने के लिए. तो मान लेते हैं मेरे पास एक कंटेनर है, इस कंटेनर में सॉल्यूशन है, मैंने यहां से ड्राई एयर बबल करी इस कंटेनर में और यहां से इसे मूव करा लिया, एंड देन आई मेड इट पास थ्रू अनदर कंटेनर. The other container contained pure H2O, which means pure solvent. And then it was made to pass through anhydrous calcium chloride, and from the outlet dry air will come out. Now what is happening in this entire experiment is that when dry air will move through this solution, and assume this solution is aqueous solution right now, so this dry air does not contain any water molecules. ठीक है? अब आपने gaseous state में पढ़ा होगा या states of matter वाले जो chapter उसमें पढ़ा होगा कि gases move from their higher partial pressure region to their lower partial pressure region. So if dry air will move here, because there is a solution, an aqueous solution, there would be some water vapors which would diffuse into the dry air. तो ये dry air जब यहाँ से जाएगी इधर वापस इस वाले दूसरे कंटेनर में मूव कर रही होगी, then this dry air will no more be a dry air, it will be a moist air, because it would now carry certain water vapors which were present in this container. ठीक है? अब ये moist air यहाँ पर पहुंची और यहाँ पे देखा इसमें और water vapors हैं, एंड यहाँ पे जो वाटर वेपर्स ऑलरेडी प्रेजेंट है इनका पार्शियल प्रेशर अभी भी ज्यादा है, मतलब जो इसके अंदर प्रेजेंट है, तो यानी कि कुछ और वाटर वेपर्स ये और कैरी कर लेगी, तो व्हिच मींस आई कैन से दैट दिस इज पार्शियली मॉइस्ट एंड दिस इज लाइक मोर मॉइस्ट एयर. सो फर्दर मोर मॉइस्ट एयर will then pass through the anhydrous calcium chloride, which will absorb all the H2O, and the dry air will come out. Now from this solution some water vapors were removed and were carried by dry air, so the mass of this solution will decrease. Some water vapors were carried away by dry air, or I would say moist air here. So mass of the solution would decrease, and water vapors were absorbed in this case. So mass of this calcium chloride tube will increase. इन इस क्वेश्चन में हमें इसके बारे में कोई बात नहीं करी है. इस क्वेश्चन में हमें ये दो सिचुएशंस दी हैं. तो ये बोल रहा है कि ये सॉल्यूशन जो है, द सॉल्यूशन इज दिस 5 ग्राम solute in 80 ग्राम solvent, and this is pure water which you have got. तो दो इसमें मास का डिक्रीज आ रहा है 2.5 ग्राम और इसमें मास का डिक्रीज आ रहा है 0.04 ग्राम. So this is the theory background of the experiment and the question. Now solve it. Should we discuss now? देखो, so एक चीज समझते हैं, यहाँ पे क्या हो रहा होगा. The moment this dry air will move here, this dry air does not contain any water vapors. ठीक है? So whatever water vapors present here will try to diffuse into the dry air. और तब तक डिफ्यूज करते रहेंगे जब तक उस ड्राई एयर में जो मॉइस्चर है यानी कि वाटर वेपर्स हैं और वाटर वेपर्स जो यहाँ पर प्रेजेंट है दोनों का पार्शियल प्रेशर बराबर नहीं हो जाता, तब तक ये वाटर वेपर डिफ्यूज करते रहेंगे. अब आप कहोगे यार ये तो यहाँ पे डिफ्यूज कर गए तो यहाँ तो कम हो जाना चाहिए, तो यानी कि इनके मिड पॉइंट पे वैल्यू बराबर आनी चाहिए, लेकिन बट होगा नहीं, बिकॉज यहाँ पे जो इस सोल्यूशन में वाटर है, दिस इज मेंटेनिंग एन इक्विलिब्रियम विद द वाटर वेपर्स. द मोमेंट ये वाटर वेपर एयर में डिफ्यूज करेंगे तो यहाँ से और वाटर वेपर्स बनने लग जाएंगे. समथिंग सिमिलर टू कि हमारे कपड़े कैसे सूखते हैं, जो भी वेट क्लोथ है उसके अराउंड वाटर वेपर्स होगा, सो द एयर ड्राई एयर वुड कम, moisture would diffuse in, and this equilibrium will get disturbed, will move in the forward direction, which means H2O liquid to H2O gas. So more water vapors will form, वो फिर air में फिर diffuse करेंगे and then so forth. तो इस dry air में कितने total water vapors diffuse करेंगे, या उनको हम ऐसे मान लेते हैं, उनका pressure कितना होगा जितना water vapor diffuse करेंगे. So that pressure of the water vapors that will diffuse in will be equal to pressure of the water vapors originally present here. ठीक है? So I can say that loss in weight of solution is directly proportional to solution के ऊपर water vapors का pressure कितना होगा? PS. अब ये मैंने PS क्यों लिया, रीजन बताता हूं. बेसिकली क्या होगा, तो मैंने कहा कि यहाँ पे जितने वाटर के मॉलिक्यूल्स हैं वो सारे के सारे एयर में डिफ्यूज कर जाएंगे. ठीक है? सारे के सारे क्यों करेंगे, क्योंकि यहां पर कितने वाटर वेपर में होने चाहिए जिनका प्रेशर PS हो, तभी इक्विलिब्रियम मेंटेन हो सकता है. अगर थोड़े से भी डिस्टर्ब होंगे तो वापस से ये बनाएगा, और ये इक्विलिब्रियम सिर्फ किस पे डिपेंड कर रहा है, टेंपरेचर पे, व्हिच वी आर नॉट चेंजिंग. तो यानी कि वाटर हमेशा यहाँ पर जो अपना सोल्यूशन है, यहाँ पर वाटर वेपर्स का प्रेशर कितना मेंटेन करके रखेगा, PS. तो यहाँ पर कब तक डिफ्यूज होते रहेंगे, PS. तो जब ये बराबर हो, तो यहाँ पे PS मेंटेन होना है, ये डिफ्यूजन कब रुकेगा, जब यहाँ पर भी सेम हो जाए. विच मीन्स एयर ने कितने वाटर वेपर्स कैरी करे, उतने वाटर वेपर्स जिनका प्रेशर पीएस था, क्योंकि बाकी सब कुछ सेम है तो प्रेशर इज प्रोपोर्शनल टू मोल्स। तो मैं कह सकता हूं कि यहाँ पे कितने वाटर वेपर्स गए, उतने वाटर वेपर्स जिनके मोल्स कितने थे, जिनका प्रेशर पीएस था, या डायरेक्टली आई कैन से दैट जिनका प्रेशर पीएस था। सेम लॉजिक यहां पर अप्लाई कर सकते हैं कि यहां पर अब जो मॉइस्ट एयर आई है, इस मॉइस्ट एयर के अंदर वाटर वेपर्स का पार्शियल प्रेशर कितना है, पीएस, और यहां पर जो ऑलरेडी कंटेनर में वाटर वेपर्स प्रेजेंट है, इनका पार्शियल प्रेशर कितना है, पी नॉट, एंड वी नो दैट पी नॉट इज ग्रेटर देन पीएस। इसका मतलब इसमें और वाटर वेपर्स डिफ्यूज करेंगे, कितने डिफ्यूज करेंगे, उतने डिफ्यूज करेंगे जिससे यहां पर पी नॉट मेंटेन रहे। तो यानी कि इसमें जो यहां पे जो एयर बाहर निकले उसका वाटर वेपर का पार्शियल प्रेशर बढ़कर पी नॉट हो जाना चाहिए। पहले कितना था, पीएस, बढ़कर कितना हो गया, पी नॉट। तो डिफ्यूज कितने करे, डिफरेंस ऑफ द टू, सो लॉस इन weight of solvent container will be proportional to P naught minus PS. So now if I divide the two, let me just rub the diagram. So now if I divide the two, the loss in weight of solution is how much the loss in weight was, 2.5 gram, and weight of solvent was 0.004 gram, 0.04 gram. So this will be proportional to PS upon P naught minus PS. Now this is an expression which can be converted to number of moles of solute upon number of moles of solvent. If you just put the value of PS, P naught, mole fraction of solvent, 1 minus mole fraction of solvent, 1 mole fraction of solute, and so on. So small n is representing number of moles of solute, and capital N is representing number of moles of solvent. Right? So now 2.5 upon 0.0004 is equal to, so moles of solute, I do not know the molecular weight of solute, so let's take weight upon molecular weight of solute into weight upon molecular weight of solvent. Right? So solute का मास हमें दिया हुआ है कितना है, 5 ग्राम, which we have taken. Solvent का मास हमें दिया हुआ है कितना है, सॉरी ये m तो हमें निकालना है, this is the 5 gram which is given to us. Solvent का मास हमें दिया हुआ है कितना है, 80 grams. Molecular weight of solvent is 18. So this will give us the molar mass of solute. Should I erase this one? The next problem is on electrochemistry. The question is that we have a cell represented by the cell notation. Right? So you have to identify the condition at which cell will be functioning or spontaneous. So you can take a minute or two and just give it a shot, then we'll discuss. Okay, so let's discuss the question. So as I can see in this question, this part would be the anode part and this part would be the cathode part. So at anode, the reaction which is happening here is H2 is forming 2H plus aqueous and losing 2 electrons. At cathode, hydrogen ions are getting reduced. Now if I add the two to figure out the cell reaction, it seems to me कि ये सब कुछ कट जाएगा. But we cannot just like cut these species from the cell reaction, deduct these species from the cell reaction, because all of them do not have the same concentration. I can remove hydrogen because both have same pressure, but H plus ion ka concentration is not same. So the equation would come out to be like concentration of H plus ion aqueous. This is at this one is at cathode to the concentration of H plus ion aqueous at anode. So if I write the cell reaction, it will be E cell is equal to E naught cell minus RT upon 2F, or I would say 2.303 RT upon 2F log of concentration of H plus ion at anode upon concentration of H plus ion at cathode ka whole square. So that 2 will come out. Right now, E naught cell of this reaction will be 0, because both of them are standard hydrogen electrodes. If I just calculate their standard potentials, whether it's oxidation potential or standard reduction potential, so E naught cell will be 0. So such type of cells are actually called concentration cells. That they're not functioning on the basis of nature of the substance present at anode and cathode. In fact, they're same. They're functioning only on the basis of differences in the concentration of the substances. Right? So I can change the concentration of the electrolyte, so it will be called as electrolytic concentration cell. I can change the concentration of the electrode, then it will be called as electrode concentration cell. So let's, if E naught cell is 0, then E cell would become minus 2.303 RT. I'll take the 2 out. So F log of concentration of H plus at anode, which is C1, and concentration of cathode at is C2. So since there is a minus sign, the cell will be spontaneous if E cell is positive. So it will be positive if C2 by, so cell will be positive, or sorry, spontaneous if E cell is positive. E cell will be positive if the value of this log portion will come out to be negative, right? So for that, C1 upon C2 has to be less than 1. So I can say that C1 is less than C2 is the condition at which the cell will become spontaneous. So similarly, I can just change and just make different kind of questions. Like I would just change the, instead I would take the concentration same and would change the pressure P1 atm and P2 atm. This is 1 molar and this pressure would be P2 atm. So अब इस पे पूछ लेंगे कि what is the condition for the spontaneity of the cell. Should I erase this? Now guys, let's see a problem on solid state. Everyone has heard of diamond, right? So I have a diamond which is nothing but like pure carbon. So it's a three-dimensional lattice of carbon. So every carbon is sp3 hybridized, right? So diamond का structure भी जैसे solid state में सबका हम बनाते हैं, face centered cubic, body centered cubic, शायद उनमें से किसी एक category में fall करना चाहिए. So what we figured out that in diamond what happens that the carbon atoms are forming face centered cubic unit cell, or I can say that they're undergoing cubic close packing. एक ही बात है, cubic close packing बना रहे हैं तो जो unit cell बनेगा that will be face centered cubic. ठीक है. दूसरे type of carbon के atoms जो हैं, मतलब so actually वो same ही है, उनकी position के हिसाब से मैं उनकी type differentiate कर रहा हूँ. तो दूसरे type के जो carbon atoms हैं they are occupying certain voids. ठीक है. तो आपको ये आइडेंटिफाई करना है कि कौन से voids और कितने परसेंट void. फॉर एग्जांपल, आर दे ऑक्यूपाइंग 100% octahedral voids, or they occupying 50% octahedral voids, or are they occupying 100% tetrahedral voids, or they occupying 50% tetrahedral voids. Which one? Should we discuss? Okay, so to just crack this problem, so there are two approaches. One is you already know what happens in a diamond structure, right? So the moment you know it, you would say, okay, this is the answer, or this is the answer, or whatever. And another approach is I do not know what exactly is diamond structure, but I can apply my knowledge of chemical bonding and solid state and try and solve this problem. So we'll solve the problem by this method, and then obviously second would be like become visible to you, right? So in first case, so I can see that carbon is making cubic close packing. It means it's forming a face centered cubic lattice, which means all the carbon atoms are present at corners and face centers of every face. Now, the void which would be present would be either octahedral or tetrahedral. Okay. So let's understand what happens in an octahedral void and how an octahedral void is formed. So octahedral void is formed when you have 4 atoms in one plane attached to each other, something like this. So there would be a space in between. One atom is occupying that space from the top, another atom is occupying the space from the bottom. So there are 6 atoms, 4 in one plane, one above, one below. So if I join the centers of these 4 atoms, they'll form a square. If I join the center of this top atom and with the corners of these 4 atoms, it will form a pyramid, right? और ये pyramid जो बना, that is a square based pyramid similar to Egyptian pyramid kind of thing. ऐसे नीचे वाले center को अगर मैं जोड़ दूं उस पे, तो it will become another pyramid, that will become a square bipyramidal geometry. This geometry is called octahedron when this geometry is perfect in the sense that all the triangles which is being formed, जैसे अगर आप Egyptian pyramid देखो तो 4 triangles बनेंगे, तो यानी कि इस पिरामिड में ऊपर 4 ट्रायंगल होंगे, नीचे भी 4 ट्रायंगल होंगे, तो सारे ट्रायंगल्स अगर इक्विलेटरल ट्रायंगल हो, सो दैट ज्योमेट्री विल बी octahedron and the space which is left in between is called octahedral. तो अगर मैं इस खाली स्पेस में एक दूसरा एटम रख दूं जो छोटा है इन सब से, ठीक है, और इन 6 एटम से वो बॉन्ड बना रहा है, तो अब यहां पे मैं केमिकल बॉन्डिंग का नॉलेज यूज करूं तो क्या हो, तो एक सेंटर में एटम है जो 4 एटम से बॉन्ड कर रहा है इन वन प्लेन, जो आपस में जोड़ के स्क्वायर बन रहा है, एक एटम से ऊपर बाइंड कर रहा है, एक एटम से नीचे बाइंड कर रहा है, तो इसका हाइब्रिडेशन कितना हो जाएगा, sp3d2, राइट? सो यानी कि द एटम व्हिच इज देयर एट द octahedral void and forms a bond with all the atoms forming octahedral void, the hybridization of the atom present at octahedral void will be sp3d2. now तो इसका मतलब कोई भी कार्बन का हाइब्रिडेशन sp3d2 हो नहीं सकता, तो इसका मतलब वो octahedral voids पे नहीं प्रेजेंट है, ठीक है? Now let's look at the tetrahedral void. So tetrahedral void क्या होता है, इसको समझने के लिए टेट्राहेड्रन समझते हैं क्या होता है. तो टेट्राहेड्रन में कुछ भी नहीं होता, आपके पास अगर 3 पॉइंट में ले लूं और उनसे एक इक्विलेटरल ट्रायंगल बनाऊं, एक पॉइंट बीच में कहीं पे लूं, उसको हवा में ले जाऊं एंड उस पॉइंट से मैं इन तीनों पॉइंट्स को जोड़ दूं, तो आई विल फॉर्म अ पिरामिड अगेन. दिस पिरामिड इज अ ट्रायंगुलर बेस वाला पिरामिड, तो ट्रायंगुलर पिरामिड काइंड ऑफ ज्योमेट्री हो गई. इस पॉइंट की अगर मैं हाइट को बहुत ऊपर ले जाता हूं, तो जो साइड्स में ट्रायंगल बनेंगे दे विल नॉट बी इक्विलेटरल. लेकिन अगर मैं इसकी हाइट ऐसे एडजस्ट करूं कि all the 3 triangles on the faces and the 1 triangle at the base, all 4 triangles are equilateral triangle, then this perfect geometry is called tetrahedron. This geometry can be seen here in tetrahedral void. कैसे? अगर मेरे पास 3 atoms हैं एक प्लेन में रखे हुए हैं ऐसे, मैं इन तीनों के सेंटर को जोड़ दूंगा तो मुझे ट्रायंगल मिल जाएगा, ठीक है? इन तीनों के जो गैप है, इन 3 एटम रखोगे गैप क्रिएट होगा, उस गैप के ऊपर आपने 4th एटम रख दिया, उस एटम के सेंटर से अगर मैं इन तीनों को जोड़ूंगा तो क्या होगा, सारे डिस्टेंसेस विल बी 2r 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 2r, यानी कि ऑल द ट्रायंगल्स आर इक्विलेटरल ट्रायंगल, व्हिच मींस on joining the centers of all the 4 atoms you are generating a tetrahedron. So the space inside or the void inside these 4 atoms is called tetrahedral void. Now if the atom inside this tetrahedral void is binding with all these 4 atoms, its hybridization will become sp3 because it will be, the geometry will be tetrahedral geometry. So यानी कि है होना ही क्या चाहिए in that case, tetrahedral. तो हमारा 50% of the problem solve हो चुका है. अब हमारा क्वेश्चन बचता है इस पे कि whether it's 100% tetrahedral void or is it 50% tetrahedral void, ये हमें आइडेंटिफाई करना होगा. सो इसमें कोई अप्रोच लगा सकते हैं. सो एक चीज क्लियर है, सो एनी कार्बन व्हिच इज प्रेजेंट एट द void will be at the tetrahedral void, that is for sure. Now will they occupy all the tetrahedral voids or will they occupy half of them? Okay, so let's see. So now if I just look at the carbon which is forming the lattice, right? ये वाले कार्बन भी sp3 हाइब्रिडाइज होंगे, ठीक है? तो अगर मैं कोई भी कॉर्नर का एटम एज्यूम करूं, तो ये कॉर्नर का एटम टचेस द टेट्राहेड्रल वॉइड and this corner atom is shared between 8 unit cells, so it will be touching 8 tetrahedral voids, or in a way I would say it would be forming bonds with 8 tetrahedral voids if all the tetrahedral voids are filled, which is not possible. This carbon would be touching actually would be forming 4 bonds and would be sp3 hybridized, and that can only possible if I fill only half of the tetrahedral void. In fact, there is also one more catch in this which is not there in the question, that is these tetrahedral voids should be alternately filled. अगर वो फॉर एग्जांपल कॉर्नर का एटम है और चारों एक ही प्लेन में वो 4 एटम्स आ गए, तो हाइब्रिडेशन sp3 नहीं बनेगी. So it has to be one in this direction, one in this direction, another in this direction, or in another direction, so that they'll be forming a tetrahedral geometry. So I can remember that from this question that in diamond, one of the carbon atoms forms CCP and other carbon atoms occupy alternate tetrahedral voids. Okay, so let's discuss the other, just last problem of the day. How many stereoisomers of monochlorinated products of, there could be more products, I don't know, right? How many stereoisomers of the monochlorinated product of butane and butane, I would say, are possible or would form in this case? So सिर्फ मोनोक्लोरिनेशन कराना है, यानी कि एक ही हाइड्रोजन को सब्स्टिट्यूट करना है किसी भी केस में, तो आप अलग अलग पॉसिबिलिटीज देख सकते हो. कौन कौन से? ठीक है. If I make it isopropyl, okay, I don't understand isopropyl thing. Let's see. So they're like two. These two positions are similar. These two positions are similar. So they're like two possibilities. One is I have removed one of the hydrogen from either of the two. They both are same, and I remove one of the hydrogen from the other ones, terminal one. I'll get this one, right? So I have to identify what stereoisomers, or I would just like change the question to be like instead of calculating all the stereoisomers, let's just focus on the optical isomers, right? So if I see, there would be no optical isomer present in this part because there is no chiral carbon, and there would be optical isomer present in this carbon. Why? Because there is a carbon which contains all the four different groups. ठीक है, so मतलब I just give you a brief around this small thing. So तो इसके basically दो isomers बन जाएंगे. तो chirality का concept बहुत simple होता है, कुछ भी नहीं है. So ये chirality simply means asymmetry. जैसे कि अगर हमारे ये दो हाथ हैं, तो they seem to be very symmetrical. They seem to be in fact same. But ये different हैं क्योंकि fingers का जो arrangement का order है वो different है. And that is why their function of gripping would be different. Right? सेम चीज यहां पर होती है कि यहां पर अगर मेरे पास इसका दूसरा आइसोमर भी देखूंगा जो ऑप्टिकल आइसोमर, उसमें भी ये चारों ग्रुप होंगे, लेकिन इन चारों ग्रुप को अगर आप रिलेटिव अरेंजमेंट देखोगे कि पहले ये ग्रुप आ रहा है, फिर दूसरा ये आ रहा है, तीसरा ये आ रहा है, सो दैट रिलेटिव अरेंजमेंट वुड बी डिफरेंट इन द टू केसेस. नाउ कायरलिटी कैसे आप आइडेंटिफाई कर सकते हो? यूजिंग कायरल सेंटर्स. अगर किसी भी मॉलिक्यूल में एक ही कायरल सेंटर है तो आप बोल सकते हो फॉर श्योर कि दैट दिस कंपाउंड विल बी ऑप्टिकली एक्टिव एंड देयर वुड बी टू ऑप्टिकल आइसोमर्स. अगर एक से ज्यादा है, देन यू हैव टू चेक कि उसमें कोई प्लेन ऑफ सिमेट्री है, सेंटर ऑफ सिमेट्री है या एक्सिस ऑफ सिमेट्री है. उसके बेसिस पे देन अगर वो कोई भी एलिमेंट ऑफ सिमेट्री नहीं मिलता, देन यू कैन से कि भाई वो कंपाउंड भी ऑप्टिकली एक्टिव है और उसके फिर अकॉर्डिंगली आइसोमर्स आप निकाल सकते हो. सो दिस इज इट. लाइक आई थिंक सम क्वेश्चंस वी कुड कवर टुडे. देयर आर स्टिल लॉट ऑफ क्वेश्चंस पेंडिंग. वी वुड बी will mail you the solution of those doubts which are left, which we could not discuss in the classroom right now. Okay, thank you.